The concept that Earth's history might repeat itself in vast cycles finds its most compelling foundation in an astronomical phenomenon that ancient civilizations understood with remarkable precision: the precession of the equinoxes. This slow, wobbling motion of Earth's axis traces a complete circle against the backdrop of stars every 25,920 years, a period that ancient astronomers called the Great Year or Platonic Year. Unlike the familiar annual cycle that governs our seasons, this cosmic clock operates on a scale that dwarfs human lifespans. Yet evidence suggests that multiple ancient cultures not only recognized its existence, but built entire cosmological systems around its rhythm. The mechanics of precession result from gravitational forces exerted by the Sun and Moon on Earth's equatorial bulge, causing our planet's rotational axis to slowly shift its orientation in space. This movement resembles the wobble of a spinning top as it slows down, though Earth's wobble occurs at an almost imperceptibly gradual rate. The practical effect manifests in the gradual shift of the spring equinox point along the ecliptic, moving backward through the zodiacal constellations at approximately 1 degree every 72 years. This means that the pole star changes over millennia. While Polaris currently marks true north, the ancient Egyptians oriented their pyramids toward Thuban in the constellation Draco, which served as their pole star around 3000 BC. Ancient Egyptian astronomical knowledge demonstrates a sophisticated understanding of these vast temporal cycles that extends far beyond what conventional archaeology typically attributes to early civilizations. The precision with which the Great Pyramid of Giza aligns with cardinal directions, accurate to within 3/60ths of a degree, suggests not merely advanced surveying techniques, but a deep comprehension of celestial mechanics. The pyramid's internal passages track specific stars across different epochs, with the so-called air shafts pointing toward Orion and Draco at precise moments in the precessional cycle. The pyramid texts, among humanity's oldest religious writings, contain references to stellar cycles and cosmic ages that span thousands of years, describing the soul's journey through different celestial realms that correspond to precessional periods. Egyptian temple architecture reveals additional evidence of this astronomical sophistication. At Dendera, the famous zodiac ceiling depicts not just the familiar constellations, but includes precession-related imagery showing the gradual shift of celestial positions over vast time periods. The temple's orientation aligns with specific stars at different epochs, suggesting that its builders understood how stellar positions change across millennia. Hieroglyphic texts from various dynasties reference great returns and cosmic cycles measured in tens of thousands of years, terminology that mirrors the language used to describe precessional periods in other ancient cultures. The Maya civilization developed perhaps the most mathematically precise calendar systems in human history, incorporating multiple interlocking cycles that track time periods ranging from single days to spans exceeding 63 million years. Their long count calendar, which measures time from a mythical creation date in 3114 BC, operates on a base 20 system that naturally accommodates vast chronological scales. Within this framework, the Maya recognized several significant cycles, including the 5 125-year Baktun and larger periods that closely approximate precessional calculations. Maya astronomical codices contain remarkably accurate calculations for planetary movements, eclipse predictions, and stellar positions that demonstrate their awareness of long-term celestial patterns. The Dresden Codex includes Venus tables that remain accurate across multiple centuries, while also referencing greater cycles that encompass thousands of years. At sites like Chichen Itza and Palenque, architectural alignments track not only solar and lunar phenomena, but also the movements of planets and stars across extended periods that correspond to precessional subdivisions. The Maya concept of cyclical time destruction and renewal appears throughout their creation mythology, where the current world represents the fourth or fifth iteration of reality, with previous worlds ending in cosmic catastrophes separated by vast time periods. These intervals, when calculated through their various calendar systems, consistently align with subdivisions of the precessional cycle, suggesting that Maya astronomers understood the connection between celestial mechanics and terrestrial change. Hindu cosmology presents the most elaborate and mathematically sophisticated treatment of cyclical time in ancient literature, with the Yuga system describing 4 ages that repeat in endless succession. According to texts like the Mahabharata, Vishnu Purana, and Surya Siddhanta, these cycles operate on multiple scales, from individual yugas lasting thousands of years to vast kalpas spanning billions of years. The most relevant to our investigation involves the 24,000-year cycle described in several ancient sources, which closely approximates the precessional period. The traditional Yuga cycle describes 4 ages of declining virtue and increasing chaos: the Satya Yuga, Treta Yuga, Dvapara Yuga, and Kali Yuga. Classical interpretations assign durations of 4,800, 3,600, 2,400, and 1,200 divine years respectively to these periods, totaling 12,000 divine years for a complete cycle. When doubled to include both ascending and descending phases, this creates a 24,000-year period that remarkably parallels the precessional cycle. The Mahabharata contains specific references to this 24,000-year cycle in its description of cosmic time, stating that 12,000 divine years constitute the cycle of the 4 yugas, and that this cycle repeats in both ascending and descending phases. The text describes how human civilization rises and falls in conjunction with these cosmic rhythms, with technological and spiritual advancement reaching peaks during the Satya Yuga, before gradually declining through subsequent ages until renewal begins again. Ancient Hindu astronomical texts demonstrate sophisticated understanding of precession through their calculations of the Ayanamsha, the gradual shift of the spring equinox point relative to fixed stars. The Surya Siddhanta, composed sometime between the 4th and 6th centuries AD but claiming much earlier origins, provides mathematical formulas for calculating this shift that closely match modern astronomical values. The text describes how the equinoctial points move along the ecliptic in a cycle lasting approximately 25,920 years, terminology that explicitly connects astronomical observation with the Yuga system. Plato's dialogues contain some of the earliest Western references to great cycles of time and cosmic renewal, though his treatment remains more philosophical than mathematical compared to Hindu or Maya sources. In the Timaeus, Plato describes how celestial bodies return to their original positions after vast periods, creating what he terms the perfect year. This concept appears linked to his understanding of cosmic harmony, where mathematical ratios governing musical intervals also determine temporal cycles and planetary movements. The Critias presents Plato's account of Atlantis within a framework of cyclical catastrophe and renewal, describing how advanced civilizations rise and fall in response to cosmic forces operating across thousands of years. While modern scholars debate the historical reality of Atlantis, Plato's narrative structure reveals his belief in recurring patterns of human development tied to astronomical cycles. He describes how many great deluges have taken place during the 9,000 years since Athens' legendary conflict with Atlantis, suggesting awareness of regular catastrophic intervals. Plato's Republic contains additional references to the Great Year of Being, a cosmic cycle during which all celestial bodies return to their original configuration. He connects this astronomical phenomenon to political and social cycles, arguing that human societies undergo predictable patterns of rise and decline that mirror celestial rhythms. This philosophical framework influenced subsequent Greek and Roman thinkers, including Cicero and the Stoics, who developed more elaborate theories connecting cosmic cycles to historical patterns. The precision with which these diverse ancient cultures independently arrived at similar cyclical periods raises profound questions about the sources of their astronomical knowledge. The 24,000, 26,000 year cycles described in Hindu, Maya, Egyptian and Greek sources all fall within the range of the actual precessional period, yet calculating this phenomenon requires centuries of careful observation and mathematical sophistication that challenges conventional timelines for human technological development. Archaeological evidence from sites like Göbekli Tepe in Turkey, dated to approximately 11,500 years ago, reveals sophisticated astronomical alignments and symbolic systems that suggest advanced understanding of celestial cycles among hunter-gatherer populations. The site's massive stone pillars track stellar movements across different epochs, while its carved symbols appear to reference cosmic events and temporal cycles that extend far beyond the lifespans of its builders. Similar patterns emerge at megalithic sites across Europe, where stone circles and burial chambers demonstrate precise astronomical orientations that account for precessional changes over thousands of years. Newgrange in Ireland, constructed around 3200 BC, aligns with the winter solstice sunrise with such precision that its builders must have understood how this alignment would shift gradually due to precession. The monument's internal passages and external stone arrangements suggest awareness of longer cycles that encompass multiple precessional periods. The astronomical knowledge preserved by ancient civilizations takes on new significance when examined alongside geological evidence that reveals Earth's climate and environmental systems have indeed undergone dramatic cyclical changes throughout recorded history. The most compelling example of this pattern emerges from the Younger Dryas period, a sudden and severe climate event that occurred between 12,900 and 11,700 years ago. This millennium-long episode of rapid cooling interrupted the gradual warming that followed the last ice age, plunging much of the northern hemisphere back into near-glacial conditions within decades. The Younger Dryas represents one of the most dramatic climate shifts documented in Earth's geological record, with temperatures dropping by as much as 15 degrees Celsius in some regions within a single generation. Ice core data from Greenland reveals that this transition occurred with startling rapidity, with some indicators suggesting the shift from warming to cooling happened within a single decade. The event's timing proves particularly intriguing when considered within the framework of cyclical catastrophe theories, as 12,900 years ago places it almost exactly at the theoretical halfway point of the current 920-year precessional cycle. Geological evidence for the Younger Dryas appears across multiple continents in the form of distinctive sediment layers, pollen records, and glacial deposits. In North America, researchers have identified what they term the black mat, a dark carbon-rich layer found at archaeological sites across the continent that corresponds precisely to the Younger Dryas boundary. This layer contains elevated levels of iridium, microscopic diamonds, and other materials typically associated with cosmic impacts, leading some researchers to propose that an extraterrestrial event triggered the climate catastrophe. The ecological devastation associated with the Younger Dryas extended far beyond simple temperature changes. Pollen records from lake sediments show massive forest die-offs across North America and Europe, with temperate woodlands replaced by tundra vegetation within centuries. Large mammal populations collapsed during this period, with species like mastodons, giant ground sloths, and saber-toothed cats disappearing from the fossil record. Archaeological evidence suggests that human populations also suffered significant disruption, with the Clovis culture of North America vanishing abruptly at the Younger Dryas boundary. The end of the Younger Dryas proved equally dramatic, with temperatures rising rapidly around 11,700 years ago to levels that would remain relatively stable throughout the Holocene period. This transition marks the beginning of what geologists term the current interglacial period, characterized by the climate conditions that enabled the development of agriculture and complex civilizations. The precise timing of this transition, occurring approximately 11,700 years ago, places it at another significant point within the theoretical 25,920-year cycle, roughly 13,200 years after the previous quarter cycle marker. Ice core analysis from both Greenland and Antarctic drilling projects provides the most detailed record of these cyclical climate patterns, with some cores extending back over 400,000 years. The data reveals recurring patterns of rapid climate change that appear to follow regular intervals, though the complexity of Earth's climate system means these cycles manifest differently in various regions and time periods. Greenland ice cores show particularly clear evidence of what researchers term Dansgaard-Oeschger events, rapid warming and cooling cycles that occur roughly every 1,500 years throughout glacial periods. When examined across longer time frames, these ice core records reveal larger patterns that align with astronomical cycles. Temperature reconstructions show major climate transitions occurring at intervals that correspond to precessional subdivisions, with particularly dramatic changes appearing every 12,000 to 13,000 years. The oxygen isotope ratios preserved in annual ice layers provide precise measurements of ancient temperatures, while trapped air bubbles contain samples of ancient atmospheres that reveal changes in carbon dioxide, methane, and other greenhouse gases across these cycles. Volcanic activity recorded in ice cores displays its own cyclical patterns that may correlate with these broader environmental changes. Major volcanic eruptions leave distinctive acid spikes in ice core records, and analysis of these signatures reveals clustering of volcanic activity during periods of rapid climate change. The Lasche Sea eruption in Germany, which occurred around 12,900 years ago, at the onset of the Younger Dryas, represents one of the largest volcanic events in European prehistory. Similar clustering of volcanic activity appears at other transition points in the geological record, suggesting possible connections between astronomical cycles, crustal instability, and climate change. The relationship between mass extinction events and these cyclical patterns becomes apparent when examining the fossil record across multiple geological periods. While the famous Cretaceous-Paleogene extinction that eliminated non-avian dinosaurs 66 million years ago resulted from an asteroid impact, many other mass extinctions appear to follow more regular patterns that may relate to astronomical cycles. The end-Pleistocene megafauna extinctions that occurred during the Younger Dryas represent the most recent example of this pattern, but similar events appear throughout the geological record at intervals that suggest cyclical causation. Research into cosmic impact theories has gained momentum following the discovery of impact markers associated with the Younger Dryas boundary. The presence of nanodiamonds, shocked quartz, and other high-pressure minerals in sediment layers from this period suggests that Earth encountered extraterrestrial material around 12,900 years ago. Some researchers propose that a comet or asteroid fragment struck North America, triggering the massive wildfires and climate disruption that characterized the Younger Dryas onset. The Taurid meteor complex, which Earth encounters twice annually, contains debris from Comet Encke and potentially other fragmented comets that may pose cyclical impact risks. Astronomical calculations suggest that Earth's orbit brings it into closer contact with this debris field at regular intervals related to precessional cycles. During peak encounters, the probability of significant impacts increases dramatically, potentially explaining the apparent correlation between astronomical cycles and catastrophic events in Earth's history. Geomagnetic field behaviour provides another line of evidence for cyclical patterns in Earth's systems. The Lachamp geomagnetic excursion, which occurred approximately 41,000 years ago, represents one of the most dramatic examples of magnetic pole instability in recent geological history. During this event, Earth's magnetic field strength dropped to less than 10% of its current value, and the magnetic poles wandered significantly from their normal positions. The weakened magnetic field would have allowed increased cosmic radiation to reach Earth's surface, potentially affecting climate systems and biological processes. Analysis of paleomagnetic records reveals that geomagnetic excursions and pole reversals occur at irregular but somewhat predictable intervals, with major events appearing roughly every 12,000, 13,000 years during certain periods. The Blake event around 120,000 years ago, the Mono Lake excursion at 34,000 years ago, and the Lachamp excursion at 41,000 years ago represent recent examples of this pattern. Each of these events coincided with significant environmental changes, including shifts in ocean circulation patterns and regional climate disruptions. The mechanism linking geomagnetic instability to surface environmental changes remains debated, but several theories propose connections through cosmic ray flux, atmospheric chemistry, and cloud formation processes. During periods of weakened magnetic field strength, increased cosmic radiation could affect atmospheric chemistry, potentially influencing cloud nucleation and precipitation patterns. These effects might trigger broader climate changes that cascade through Earth's interconnected environmental systems. Ocean sediment cores provide additional evidence for cyclical environmental changes, particularly in the patterns of deep water circulation and marine productivity. The thermohaline circulation system, which drives global ocean currents, appears sensitive to the types of rapid climate changes documented during events like the Younger Dryas. Sediment records from the North Atlantic show repeated disruptions of this circulation system at intervals that correlate with other cyclical patterns in the geological record. Marine isotope records reveal cyclical changes in ocean temperature and salinity that extend back millions of years, with some patterns appearing to follow astronomical forcing mechanisms related to Earth's orbital cycles. However, higher frequency variations in these records suggest additional cyclical influences operating on timescales that match precessional periods and their subdivisions. Deep-sea drilling projects have recovered sediment sequences that span multiple complete cycles, allowing researchers to identify recurring patterns in marine ecosystems and ocean chemistry. The correlation between these various geological indicators, climate proxies, extinction events, volcanic activity, geomagnetic behavior, and marine records suggests that Earth's systems may indeed respond to cyclical forcing mechanisms operating on timescales of approximately 12,000, 13,000 years. While the precise mechanisms driving these cycles remain debated, the accumulating evidence points toward regular patterns of environmental disruption and renewal that align remarkably well with the astronomical cycles recognized by ancient civilizations. The geological evidence for cyclical catastrophes finds its most dramatic expression in the archaeological record of human civilization itself, where a pattern emerges of sophisticated societies reaching remarkable heights of achievement before vanishing almost overnight around 12,000 years ago. This period, coinciding precisely with the end of the Younger Dryas and the onset of our current interglacial period, witnessed the simultaneous collapse of advanced cultures across multiple continents, accompanied by the extinction of megafauna species that had coexisted with humans for tens of thousands of years. The end-Pleistocene megafauna extinctions represent one of the most puzzling aspects of this transition period. Massive creatures that had survived multiple ice age cycles suddenly disappeared from the fossil record within a remarkably narrow time frame. In North America, mastodons, giant ground sloths, American cheetahs, short-faced bears and dire wolves all vanished between 13,000 and 11,000 years ago. These animals had successfully adapted to previous climate fluctuations throughout the Pleistocene, yet something about the Younger Dryas period proved fatal to their continued existence. The extinction pattern shows clear geographical clustering, with the most severe losses occurring in regions that also show evidence of human cultural disruption. The American Southwest, previously home to diverse megafauna populations and sophisticated Clovis hunting cultures, became virtually depopulated of both large mammals and human settlements during this period. Archaeological sites show abrupt abandonment around 12,900 years ago, with tool traditions and settlement patterns changing dramatically when human occupation resumed centuries later. Similar patterns emerge across other continents, though with regional variations that reflect local environmental conditions. In Europe, cave bear populations that had thrived for hundreds of thousands of years suddenly collapsed, along with woolly rhinoceros and giant deer species. Australian megafauna, including giant wombats, marsupial lions, and enormous flightless birds, disappeared during roughly the same time frame, despite having survived previous climate transitions. The synchronicity of these extinctions across isolated continents suggests a global trigger rather than localized environmental pressures. The human response to these environmental catastrophes reveals sophisticated adaptation strategies that challenge conventional assumptions about prehistoric technological capabilities. Rather than simply struggling to survive, archaeological evidence suggests that some human populations responded to the crisis by developing more complex social organizations and advanced technologies. The period immediately following the Younger Dryas saw the emergence of monumental architecture projects that required unprecedented levels of coordination and technical knowledge. Göbekli Tepe in southeastern Turkey represents the most striking example of this post-catastrophe technological surge. Constructed beginning around 11,500 years ago, just as the Younger Dryas was ending, this massive complex consists of at least 20 circular stone enclosures, each containing enormous T-shaped pillars carved from single blocks of limestone weighing up to 16 tons. The precision of the stonework, the sophistication of the carved reliefs depicting various animals and abstract symbols, and the astronomical alignments of the structures all point to a level of organizational and technical capability that supposedly did not exist among hunter-gatherer populations. The site's builders demonstrated advanced understanding of quarrying, stone transportation, and precision carving techniques that would not be seen again in the archaeological record for several thousand years. The pillars feature intricate bas-relief carvings of lions, bulls, foxes, snakes, and birds, executed with artistic skill that rivals much later civilizations. More intriguingly, many of the animal species depicted had been extinct in the region for millennia, suggesting that the carvings preserved cultural memories of the pre-extinction megafauna. Astronomical analysis of Göbekli Tepe reveals alignments that track specific star positions during the period of its construction, but also incorporates knowledge of longer-term celestial cycles. The arrangement of the stone circles appears to map constellation positions across different epochs, suggesting awareness of precessional changes spanning thousands of years. Pillar 43, known as the Vulture Stone, contains symbolic representations that some researchers interpret as a star map depicting the sky during the Younger Dryas period, possibly commemorating the cosmic events that triggered the catastrophe. The deliberate burial of Göbekli Tepe around 8,000 years ago represents another mystery that fits the pattern of cyclical rise and decline. Rather than abandoning the site due to environmental pressures or cultural changes, the builders systematically covered the entire complex with thousands of tons of earth, preserving it for future discovery. This careful burial suggests intentional preservation of knowledge for future generations, possibly in anticipation of recurring catastrophic cycles. Gunung Padang in Indonesia presents evidence for even earlier advanced construction techniques, with recent archaeological investigations revealing multiple construction phases extending back potentially 25,000 years. The site consists of terrace stone platforms built into a natural hill, but ground-penetrating radar and core sampling have revealed artificial structures buried deep beneath the visible remains. The earliest construction phases show sophisticated megalithic work using precisely fitted stone blocks, some weighing several tons. Carbon dating of organic materials found within the buried structures has yielded dates ranging from 15,000 to 25,000 years ago, placing the earliest construction phases well before the supposed development of complex societies. The advanced construction techniques evident in these early phases include the use of a type of ancient concrete made from crushed rock and organic binding agents, creating structures more durable than many modern buildings. The precision of the stone cutting and fitting demonstrates technological capabilities that conventional archaeology does not associate with Paleolithic cultures. The site's layout incorporates astronomical alignments that track celestial events across multiple precessional cycles, suggesting that its builders possessed sophisticated understanding of long-term astronomical patterns. Underground chambers within the complex contain acoustic properties that amplify specific sound frequencies, indicating advanced knowledge of architectural acoustics. The overall design suggests a ceremonial complex that served multiple functions related to astronomical observation, acoustic phenomena, and possibly the preservation of cultural knowledge across long time periods. Underwater archaeological discoveries have revealed additional evidence for advanced pre-flood civilizations that were submerged by rising sea levels at the end of the last ice age. The Yonaguni monument off the coast of Japan consists of massive stone structures with precisely cut steps, terraces, and geometric patterns that appear artificial in origin. While some researchers argue for natural formation processes, the geometric precision and apparent tool marks on the stone surfaces suggest human modification of natural rock formations. Dating of the Yonaguni structures remains controversial, but the monument lies beneath 25 meters of water, placing its construction during periods of much lower sea level. If artificial, the structures would date to at least 12,000 years ago when sea levels were low enough to expose the site. The monument's design includes features that appear designed for specific functions, including what researchers interpret as ceremonial platforms, water channels, and astronomical observation points. Similar underwater structures have been discovered off the coasts of India, Malta, and other locations around the world, all submerged by post-glacial sea level rise. The Dwarka complex off India's western coast contains stone structures and artifacts that suggest a sophisticated urban centre existed on the exposed continental shelf during the last ice age. Archaeological diving has recovered pottery, tools, and structural remains that indicate advanced craftsmanship and urban planning capabilities among the site's builders. The pattern of technological regression following these early achievements represents one of the most puzzling aspects of human cultural evolution. Rather than building upon the advanced techniques demonstrated at sites like Göbekli Tepe and Gunung Padang, subsequent cultures appear to have lost much of this knowledge, only gradually redeveloping similar capabilities over thousands of years. This regression pattern repeats throughout human history, with periods of remarkable achievement followed by apparent technological decline and slow recovery. The transition from the advanced stoneworking techniques evident at early megalithic sites to the simpler construction methods of later Neolithic cultures illustrates this regression pattern clearly. The massive stone blocks and precision fitting seen at the earlier sites gave way to smaller stones and cruder construction techniques in later periods. The sophisticated astronomical alignments and acoustic properties of early monuments were not replicated in later constructions, suggesting loss of the specialized knowledge required for such achievements. This pattern of technological regression and recovery appears to operate on cycles that correspond roughly to the astronomical periods recognized by ancient cultures. Major advances in human capability appear to cluster around specific time periods, followed by gradual decline and eventual renewal. The timing of these cycles suggests possible connections to the environmental disruptions documented in the geological record, with catastrophic events periodically destroying accumulated knowledge and forcing civilizations to rebuild from reduced technological bases. The global distribution of flood myths and destruction narratives provides cultural evidence for shared memories of catastrophic events that align with the geological and archaeological evidence for cyclical disasters. Over 200 distinct cultures worldwide preserve detailed accounts of great floods that destroyed previous civilizations, with remarkable consistency in the basic narrative elements, despite geographical isolation between the cultures that preserved them. The Mesopotamian epic of Gilgamesh describes Utnapishtim's survival of a great flood that destroyed the antediluvian world, preserving knowledge and civilization for future generations. The account includes specific details about the flood's duration, the construction of survival vessels, and the gradual return of normal conditions. Similar narratives appear in ancient Egyptian texts, Hindu Puranas, Greek mythology, and indigenous traditions across the Americas, Australia, and the Pacific Islands. The consistency of these flood narratives extends beyond simple storytelling to include specific technical details about the catastrophic events. Many accounts describe the flood as lasting approximately 1 year, with specific stages of rising and receding waters. The narratives often include references to massive fires that preceded or accompanied the floods, along with descriptions of darkness that lasted for extended periods. These details correspond remarkably well with the environmental effects that would result from the cosmic impact scenarios proposed for the Younger Dryas trigger. More significantly, many of these cultural traditions explicitly connect the flood narratives to cyclical time concepts and astronomical observations. Hindu traditions describe the flood as occurring at the transition between cosmic ages, specifically at the end of previous yugas when the world undergoes renewal. Maya creation mythology places multiple flood events at specific intervals within their cyclical calendar systems, with the most recent flood occurring at a time that corresponds to the end of the last ice age. The preservation of advanced astronomical knowledge within these flood traditions suggests that the catastrophic events did not completely destroy all accumulated wisdom, but rather forced its preservation in encoded form within cultural narratives and religious systems. The mathematical precision of ancient calendar systems and the sophisticated astronomical alignments of early megalithic sites indicate that survivors of these catastrophic periods retained crucial knowledge about cosmic cycles and their relationship to terrestrial events. Analysis of genetic data from modern human populations reveals bottleneck events that correspond to the timing of these catastrophic periods, with significant population reductions occurring around 12,000 years ago across multiple continents. These genetic signatures suggest that human populations survived the environmental catastrophes, but with severely reduced numbers, forcing rapid cultural adaptation and knowledge preservation strategies. The archaeological evidence for advanced pre-catastrophe civilizations, combined with the geological record of cyclical environmental disasters and the cultural preservation of flood narratives, creates a compelling picture of human history as a series of rises and falls corresponding to astronomical cycles. Rather than linear progress from primitive to advanced states, human civilization appears to follow cyclical patterns of achievement, catastrophe, and renewal that align with the 25,000-year astronomical cycles recognized by ancient cultures worldwide. The survivors of the Younger Dryas catastrophe possessed knowledge that transcended mere survival techniques. They understood the cosmic mechanics behind the disasters that had befallen their predecessors and took deliberate steps to encode this understanding into permanent structures that could withstand future catastrophic cycles. The massive stone monuments they erected across the globe represent far more than impressive feats of engineering. They function as sophisticated astronomical computers designed to track the precession of the equinoxes and preserve crucial temporal information across millennia. The Great Pyramid of Giza stands as perhaps the most mathematically precise structure ever built, incorporating measurements that encode fundamental constants of Earth's dimensions and orbital mechanics with an accuracy that rivals modern surveying techniques. The pyramid's base perimeter of 921.45 meters when divided by its original height of 146.7 meters, yields a ratio of 3.14159 pi to 5 decimal places. This mathematical relationship appears throughout the structure's proportions, but more significantly, the pyramid's dimensions directly encode the Earth's vital statistics in a 1:43,200 scale ratio. The 43,200 scaling factor proves particularly significant when examined within the context of precessional cycles. This number represents exactly 600 times 72, the number of years required for the spring equinox point to move 1 degree along the ecliptic due to precession. The pyramid's base perimeter, when multiplied by 43,200, equals Earth's equatorial circumference to within 0.05% accuracy. Similarly, the structure's height multiplied by the same factor closely approximates the polar radius from Earth's center to the North Pole. These relationships demonstrate that the pyramid's builders possessed precise knowledge of Earth's dimensions and understood the mathematical relationships governing precessional motion. The internal passages of the Great Pyramid reveal even more sophisticated astronomical encoding. The descending passage, inclined at 26 degrees and 18 minutes, pointed directly toward Alpha Draconis around 2170 BC, when this star served as the pole star due to precession. The ascending passage, at an angle of 26 degrees and 2 minutes, aligned with Alcyone in the Pleiades cluster during the same epoch. These alignments were not coincidental but represented deliberate astronomical markers that would shift predictably as precession altered the apparent positions of stars over centuries. The King's Chamber contains the most precise astronomical alignments, with its southern shaft pointing toward Orion's belt and the northern shaft targeting Alpha Draconis during the pyramid's construction period. However, the builders incorporated additional complexity by designing these shafts to track these stellar targets across multiple precessional positions. The shaft angles account for the stars' changing positions due to precession, allowing the passages to maintain their celestial connections across different epochs of the 25,920-year cycle. Recent discoveries within the pyramid have revealed previously unknown chambers and passages that appear to extend the astronomical encoding system. Ground-penetrating radar and cosmic ray imaging have detected voids within the structure that line with additional stellar targets, suggesting a more comprehensive star mapping system than previously recognized. These hidden chambers may contain mechanisms or markers designed to track precessional changes across complete cycles, effectively creating a three-dimensional model of celestial mechanics embedded within the monument's architecture. The pyramid's relationship to the constellation Orion extends beyond simple stellar alignment to encompass the entire precessional cycle of this star group. Orion's position relative to the celestial equator changes dramatically over the 25,920-year precession cycle, reaching its lowest point around 10,500 BC and its highest around 2500 AD. The pyramid's internal geometry appears designed to track Orion's complete precessional journey, with different passages and chambers corresponding to various epochs within this vast cycle. Stonehenge demonstrates equally sophisticated astronomical encoding, though expressed through a different architectural approach that emphasizes cyclical observation rather than permanent stellar alignment. The monument's construction occurred in multiple phases spanning over 1,500 years, with each phase incorporating increasingly complex astronomical functions that suggest accumulating knowledge of long-term celestial cycles. The earliest phase of Stonehenge, dating to approximately 3,100 BC, consisted of a circular earthwork enclosure containing 56 pits known as Aubrey holes. These pits, arranged in a precise circle, function as a computational device for predicting eclipses across multiple decades. The 56-hole pattern allows tracking of the 18.6-year lunar standstill cycle, the 19-year Metonic cycle, and longer eclipse prediction sequences that extend across centuries. Archaeological evidence suggests that markers were moved around the circle according to specific patterns that enabled accurate eclipse forecasting without requiring complex mathematical calculations. The massive trilithons erected during Stonehenge's later construction phases created a more sophisticated astronomical instrument capable of tracking solar and lunar extremes across complete cycles. The monument's primary axis aligns with the summer solstice sunrise, but the healed stone and other markers track the subtle variations in this alignment caused by precession and other long-term astronomical cycles. The positioning of the trilithons creates sightlines that account for the gradual shift in solstice positions over thousands of years, suggesting that the builders understood how these alignments would change across multiple centuries. The recently discovered timber circles that preceded the stone monument reveal even earlier astronomical sophistication at the Stonehenge site. These wooden structures, dating to approximately 8000 BC, incorporated astronomical alignments that track stellar positions during the immediate post-Younger Dryas period. The timber arrangements appear designed to commemorate specific celestial configurations that existed during the catastrophic period, possibly serving as monuments to the cosmic events that triggered the environmental disasters. Analysis of the site's acoustic properties has revealed another layer of astronomical encoding within Stonehenge's design. The stone circle creates specific resonance frequencies that correspond to mathematical ratios found in planetary orbital periods and precessional calculations. Sound experiments conducted within the monument demonstrate that certain frequencies are amplified while others are dampened, creating acoustic effects that may have been used in conjunction with astronomical observations to track long-term cycles. The bluestones transported from Wales to construct portions of Stonehenge required enormous effort and sophisticated logistics, suggesting that their specific acoustic and potentially magnetic properties were essential to the monument's function. These particular stones exhibit unique resonance characteristics and contain mineral compositions that create subtle magnetic field variations. The builders may have selected these materials specifically for their ability to interact with Earth's magnetic field in ways that enhance the monument's function as an astronomical observation device. Angkor Wat in Cambodia represents the culmination of architectural astronomy, incorporating precessional calculations into a temple complex that functions as a three-dimensional model of Hindu cosmology and astronomical cycles. The temple's design explicitly references the churning of the ocean of milk, a Hindu creation myth that describes cosmic cycles and the periodic renewal of the universe. The architectural elements correspond to specific time periods within the Yuga system, with measurements that encode the durations of cosmic ages and their relationships to precessional periods. The temple's central tower represents Mount Meru, the cosmic axis around which the universe revolves according to Hindu cosmology. The tower's height and proportions encode mathematical relationships that correspond to Earth's precessional motion, with the structure's dimensions reflecting the 25 920-year cycle in various scaled ratios. The surrounding galleries and courtyards represent different cosmic realms and time periods, creating a physical map of cyclical time that visitors could navigate to understand the relationships between different temporal scales. The causeway leading to Angkor Wat's main entrance spans exactly 350 metres, a distance that corresponds to specific calculations related to the Yuga cycles and their astronomical foundations. The 108 stone figures lining each side of the causeway reference the sacred number that appears throughout Hindu astronomical calculations, and represents half of the 216-year period required for the spring equinox to move 3 degrees due to precession. These figures depict the eternal struggle between devas and asuras, representing the opposing forces that drive cosmic cycles. The temple's bas-relief galleries contain detailed astronomical information carved into stone panels that extend for hundreds of meters around the complex. These reliefs depict specific episodes from Hindu epics, but analysis reveals that the narrative sequences correspond to astronomical events and cyclical time periods. The famous churning of the Ocean of Milk relief shows 92 asuras and 88 devas pulling the cosmic serpent, numbers that relate to specific precessional calculations and eclipse cycles. The temple's orientation demonstrates sophisticated understanding of long-term astronomical changes, with its primary axis aligned to account for precession-induced shifts in stellar positions across multiple centuries. Unlike many ancient monuments that align with celestial objects at specific epochs, Angkor Wat appears designed to maintain its astronomical relationships across extended periods by incorporating the gradual changes caused by precession into its fundamental geometry. The star clock theory emerges from analysis of how these ancient monuments collectively function as temporal measurement devices operating on scales far exceeding human lifespans. Rather than simply marking annual solar cycles or shorter astronomical phenomena, these structures appear designed to track the positions of specific stellar markers across the complete 25 920-year precessional cycle. The builders understood that certain stars would serve as reliable temporal indicators, rising and setting at specific times and positions that would shift predictably due to precession. Orion serves as the primary stellar timekeeper in many of these ancient systems, with its distinctive pattern making it easily recognizable across cultures and its position relative to the celestial equator providing a clear indicator of precessional phase. The constellation's annual heliacal rising, its first appearance before dawn after a period of invisibility, shifts gradually through the calendar year due to precession, creating a slow stellar clock that marks centuries and millennia rather than days and months. The builders of megalithic monuments recognized that Orion's changing position could serve as a master clock for measuring vast time periods. During the pyramid building era, around 2500 BC, Orion crossed the meridian at its lowest point in the precessional cycle, while calculations show it will reach its highest meridian crossing around 2500 AD. This 5000-year span represents roughly one-fifth of the complete precessional cycle, and monuments built during different epochs incorporate alignments that track Orion's position at their respective construction periods. Draco, the dragon constellation that contains the former pole star Thuban, provides another crucial temporal marker in ancient astronomical systems. The constellation's position relative to the celestial pole changes dramatically across the precessional cycle, with different stars within Draco serving as pole stars during different epochs. The ancient Egyptians recognized this pattern and incorporated Draco alignments into their monuments that would track the constellation's changing relationship to true north across thousands of years. The Southern Cross, visible primarily from southern hemisphere locations, appears in the astronomical traditions of civilizations in South America, Africa, and Oceania as another precessional timekeeper. This constellation's visibility from northern latitudes changes significantly due to precession, with the Southern Cross visible from Mediterranean regions around 5000 BC but invisible from these same locations today. Ancient monuments in North Africa and the Middle East incorporate alignments that suggest awareness of the Southern Cross's changing visibility patterns across precessional cycles. These stellar timekeepers collectively create a comprehensive system for measuring and predicting long-term astronomical cycles. By tracking multiple constellations simultaneously, ancient astronomers could cross-reference their observations to maintain accurate temporal measurements across centuries. The monuments they built serve as permanent observation platforms designed to facilitate these long-term measurements while also preserving the accumulated knowledge for future generations. The role of sacred sites as time capsules becomes evident when examining how these monuments preserve astronomical knowledge through their physical structures rather than relying on written records that could be destroyed during catastrophic periods. The builders recognised that stone monuments could survive environmental disasters that would eliminate libraries, archives, and other conventional knowledge storage systems. By encoding crucial temporal information into the monument's geometry, alignments, and proportions, they created knowledge preservation systems designed to function across multiple catastrophic cycles. The mathematical relationships embedded within these structures ensure that future civilizations with sufficient astronomical knowledge could decode the preserved information even without access to the original cultural contexts. The use of fundamental mathematical constants like pi and phi, along with precise astronomical measurements, creates a universal language that transcends cultural and linguistic barriers. A technically advanced civilization encountering these monuments thousands of years after their construction could reconstruct the astronomical knowledge they contain through careful measurement and analysis. The global distribution of these encoded monuments suggests a coordinated effort to preserve crucial temporal knowledge across multiple continents and cultures. Rather than isolated achievements by individual civilizations, the monuments appear to represent elements of a comprehensive knowledge preservation system designed to ensure that information about cosmic cycles and their terrestrial effects would survive future catastrophic events. The consistency of astronomical alignments and mathematical encoding across geographically separated sites indicates shared knowledge and possibly coordinated construction efforts spanning centuries or millennia. The astronomical knowledge preserved in stone monuments finds its parallel expression in the mythological traditions that ancient cultures transmitted through oral narratives, religious texts, and ceremonial practices. These stories, far from being primitive attempts to explain natural phenomena, reveal themselves as sophisticated encoding systems that preserved crucial information about cyclical catastrophes and cosmic mechanics across thousands of years. When examined comparatively across different civilizations, creation and destruction myths display remarkable consistency in their core elements, suggesting shared memories of actual events rather than independent fictional developments. The Norse cosmological system presents one of the most detailed accounts of cyclical destruction and renewal through its Ragnarok narrative, which describes the end of the current world age, followed by the emergence of a new cosmic order. The story begins with the Fimbul Winter, a prolonged period of bitter cold lasting 3 years without intervening summers, during which social order collapses and warfare becomes universal. This description corresponds closely to the environmental conditions documented during the Younger Dryas period, with its sudden onset of glacial conditions and associated social disruptions. The mythological account describes specific astronomical events accompanying the world's destruction, including the darkening of the sun and moon, the falling of stars from their positions, and the shaking of Yggdrasil, the world tree that connects the 9 realms of existence. These elements align with the environmental effects that would result from cosmic impact events, including atmospheric darkening from debris and dust, disruption of normal celestial observations, and seismic activity from impact-generated earthquakes. The Ragnarok narrative includes precise temporal elements that correspond to astronomical cycles, with the events unfolding according to specific sequences that mirror the mathematical relationships found in precessional calculations. The death and rebirth of Balder, the god of light, occurs at the cycle's midpoint, suggesting awareness of the relationship between cosmic cycles and solar phenomena. The emergence of the new world features surviving gods and humans who repopulate the renewed earth, carrying forward essential knowledge while leaving behind the corrupted elements of the previous age. Hindu creation mythology provides even more mathematically precise accounts of cyclical time through its descriptions of cosmic dissolution and recreation at the end of each kalpa. The Vishnu Purana describes how Vishnu withdraws the universe into himself during periods of cosmic night, preserving the essential elements of creation within his divine consciousness before manifesting them again in renewed form. These dissolution periods, called pralayas, occur at multiple temporal scales corresponding to different astronomical cycles. The text provides specific details about the environmental catastrophes that accompany cosmic dissolution, including the emergence of 7 suns that burn away all moisture from the Earth, followed by torrential rains that flood the entire world for extended periods. The description of multiple suns appearing in the sky corresponds to observations that might result from atmospheric phenomena during impact events, when debris and plasma effects could create the appearance of additional solar bodies. The subsequent flooding matches the environmental sequence documented in geological records of post-impact climate disruption. The Mahabharata contains additional details about cyclical catastrophes through its description of the transition between yugas, particularly the shift from Dvapara Yuga to Kali Yuga that supposedly occurred around 3100 BC. The epic describes how Krishna's departure from the world triggers a cascade of environmental and social disasters, including the submersion of Dwarka beneath the ocean, the failure of monsoon patterns, and the collapse of dharmic social order. Archaeological investigations of submerged structures off India's western coast have revealed remains consistent with the epic's description of Dwarka's inundation. The text includes specific astronomical references that connect these catastrophic transitions to celestial events, mentioning the conjunction of planets and the altered positions of constellations that accompany the age transitions. These astronomical details demonstrate sophisticated understanding of how planetary alignments and stellar positions change across long time periods, suggesting that the epic preserves actual observational records embedded within its narrative framework. Mayan creation mythology, preserved in texts like the Popol Vuh and various codices, describes multiple previous worlds that ended in catastrophic destruction before the creation of the current world age. The narrative identifies 4 previous creations, each populated by different types of beings, and each ending through specific types of disasters, floods, fires, winds, and darkness. The mathematical precision of Mayan calendar systems suggests that these destruction narratives correspond to actual temporal calculations rather than symbolic representations. The Popol Vuh describes the destruction of the third creation through a great flood that lasted for extended periods, followed by darkness that prevented the sun from rising for long intervals. The text provides specific details about the environmental conditions during these catastrophic periods, including the behavior of animals, the failure of food crops, and the breakdown of normal seasonal patterns. These descriptions match the environmental effects documented in paleoclimatic records from the Younger Dryas and earlier catastrophic periods. The Maya incorporated these cyclical destruction narratives into their calendar systems through the concept of world ages measured in baktuns and longer periods. The completion of major calendar cycles was associated with potential world renewal events, with specific dates calculated thousands of years in advance based on astronomical observations. The precision of these calculations demonstrates that Maya astronomers understood the relationship between celestial mechanics and terrestrial catastrophes across multiple cycles. Egyptian creation mythology centers around the concept of cyclical renewal through the daily death and rebirth of Ra, the sun god, but extends this pattern to vast cosmic cycles involving the complete destruction and recreation of the world. The pyramid texts describe how Ra travels through the underworld each night, battling the serpent Apophis, who represents chaos and dissolution. This nightly struggle symbolizes the ongoing tension between order and chaos that periodically results in cosmic renewal events. The Egyptian concept of the first time refers to a golden age when gods ruled directly on earth before withdrawing to celestial realms and leaving human civilization to develop independently. Texts describe this period as lasting for thousands of years and ending with great catastrophes that forced the divine beings to depart. The chronologies provided in various Egyptian sources place the end of the first time at dates that correspond roughly to the Younger Dryas period, suggesting cultural memories of pre-catastrophe advanced civilizations. The Edfu temple texts contain detailed accounts of the followers of Horus, divine beings who preserved crucial knowledge through catastrophic periods and transmitted it to subsequent human civilizations. These texts describe how the followers established sacred sites at specific locations chosen for their ability to survive environmental disasters, creating a network of knowledge preservation centers across Egypt. The mathematical and astronomical information contained in these temple texts demonstrates sophisticated understanding of cyclical time and cosmic mechanics. The world tree concept appears across numerous mythological systems as a central axis connecting different cosmic realms and serving as a temporal measuring device for vast cycles. In Norse mythology, Yggdrasil extends its roots into 3 wells representing past, present and future, while its branches support the 9 worlds of existence. The tree's periodic shaking during catastrophic events corresponds to the disruption of normal cosmic order, while its survival through Ragnarok ensures continuity between world ages. Hindu tradition describes the cosmic tree Kalpadruma, which grows and flourishes during periods of cosmic stability, but withers during dissolution phases. The tree's cycles of growth and decay correspond to the mathematical relationships governing yuga transitions, with specific time periods assigned to different phases of the tree's existence. The Puranas describe how sages and divine beings use the tree's condition as an indicator of the current cosmic age and impending transitions. The Mayan world tree, represented in their art and architecture as a Cecropia tree or stylized cross, connects the underworld, earth and celestial realms, while serving as a temporal axis around which cosmic cycles revolve. Mayan astronomical texts describe how the world tree's position relative to specific constellations indicates the current phase within longer calendar cycles. The tree's association with the Milky Way in Mayan astronomy connects terrestrial time cycles to galactic rotation and stellar precession. The axis mundi concept appears in various forms across cultures worldwide, from the Mesopotamian cosmic mountain to the Chinese Kunlun, the Greek Mount Olympus, and the Hindu Mount Meru. These cosmic centers serve similar functions as connection points between earthly and celestial realms, while providing stable reference points for measuring cosmic cycles. The architectural monuments built to represent these cosmic centers incorporate astronomical alignments and mathematical relationships that encode information about cyclical time. Analysis of the axis mundi concept reveals its relationship to precession through the imagery of cosmic rotation around a central axis. The world tree or cosmic mountain serves as the fixed center around which the celestial sphere appears to rotate, with the precession of the equinoxes representing the slow wobble of this cosmic axis. Ancient cultures understood this astronomical relationship and incorporated it into their mythological systems as a way of preserving knowledge about long-term celestial cycles. The dying and rising god archetype appears across numerous mythological traditions as a figure who undergoes cyclical death and resurrection, often in connection with seasonal changes, but also representing longer cosmic cycles. Osiris in Egyptian mythology dies and is dismembered before being reassembled and resurrected, with his death and rebirth cycle connected to the annual flooding of the Nile, but also to longer cosmic renewal periods. The myth includes specific astronomical elements, with Osiris identified with the constellation Orion, and his resurrection timed to coincide with the star's heliacal rising. The Mesopotamian Tammuz undergoes similar cycles of death and resurrection, with his descent to the underworld causing environmental catastrophes including drought, famine, and the cessation of fertility. The myth describes specific time periods for Tammuz's absence from the world, corresponding to astronomical calculations related to planetary cycles and stellar positions. His resurrection marks the renewal of natural fertility and the restoration of cosmic order. The Greek Dionysus experiences cyclical dismemberment and reconstitution, with his death and rebirth associated with both seasonal agricultural cycles and longer cosmic renewal periods. The mystery religions built around Dionysus incorporated astronomical observations and mathematical calculations that connected the god's mythological cycles to actual celestial phenomena. Initiates learned to interpret natural events and astronomical observations as manifestations of the eternal cycles represented by the dying and rising god. The world serpent appears in mythological systems worldwide as a cosmic force that both threatens and maintains universal order through its cyclical activities. The Norse Jormungandr encircles the world and will emerge from the ocean during Ragnarok to poison the sky and battle the gods. The serpent's movements cause earthquakes and tidal waves, while its final battle with Thor results in mutual destruction that clears the way for cosmic renewal. Hindu mythology describes the cosmic serpent Shesha, who supports the world on his 1,000 heads and whose movements cause earthquakes and other geological disturbances. The Puranas describe how Shesha periodically shifts his position to maintain cosmic balance, with these movements corresponding to major environmental changes and civilizational transitions. The serpent's association with Vishnu connects these geological cycles to the broader patterns of cosmic preservation and renewal. The Mayan feathered serpent, Kukulkan, represents the synthesis of earthly and celestial forces, with its movements corresponding to astronomical cycles and seasonal changes. Mayan texts describe how Kukulkan's periodic appearances and disappearances mark important transitions within their calendar systems, with specific dates calculated based on the serpent's mythological activities. The architectural representations of Kukulkan at sites like Chichen Itza create shadow effects during equinoxes that demonstrate the connection between mythological narratives and astronomical observations. The cosmic egg motif appears across numerous creation mythologies as the primordial container from which the current universe emerges through cyclical processes of expansion and contraction. Hindu cosmology describes the Brahmanda, or cosmic egg, which contains all possibilities for manifestation and undergoes repeated cycles of expansion during creation periods and contraction during dissolution phases. The mathematical relationships governing these expansion and contraction cycles correspond to astronomical calculations related to cosmic time periods. Egyptian creation myths describe the primordial egg laid by the cosmic goose, or emerging from the waters of Nun, containing the sun god who will illuminate and organize the cosmos. The egg's periodic opening and closing corresponds to cycles of cosmic activity and rest, with specific time periods assigned to different phases of the cosmic egg's existence. These temporal calculations align with astronomical cycles and suggest sophisticated understanding of cosmic mechanics. Orphic Greek traditions describe a cosmic egg created by time and containing the primordial deity Phanes, who emerges to create the ordered cosmos. The egg undergoes cyclical processes of creation and dissolution, with each cycle producing a renewed version of reality that incorporates lessons learned from previous iterations. The mathematical relationships governing these cycles correspond to astronomical observations and suggest influence from Near Eastern cosmological traditions. The preservation of accurate astronomical information through oral traditions represents one of the most remarkable aspects of ancient knowledge transmission systems. Aboriginal Australian cultures maintained detailed astronomical observations and star maps through songlines and dreamtime narratives that remained accurate across thousands of years of oral transmission. These traditions preserve information about stellar positions, planetary movements, and celestial events that occurred during different epochs, demonstrating the reliability of oral knowledge preservation systems. Polynesian navigation traditions maintained precise astronomical knowledge through chants, stories, and ceremonial practices that enabled accurate ocean voyaging across thousands of miles. These oral traditions preserved information about star positions, seasonal changes, and navigational techniques that remained functional across many generations of transmission. The accuracy of this preserved knowledge demonstrates that oral traditions can maintain technical information with precision comparable to written records. Native American traditions across multiple tribes preserve detailed accounts of astronomical events, including meteor showers, comets, and supernovae that occurred centuries or millennia ago. These oral histories include specific details about the timing, duration, and effects of celestial events that correspond to modern astronomical calculations of historical phenomena. The consistency of these accounts across geographically separated tribes suggests shared observational traditions and systematic knowledge preservation methods. The encoding of catastrophic event memories within mythological narratives appears designed to ensure survival across multiple disaster cycles through redundant preservation systems. Rather than relying on single repositories of knowledge that could be destroyed during catastrophic events, ancient cultures embedded crucial information within multiple overlapping systems, including oral traditions, architectural monuments, mathematical relationships, and ceremonial practices. This distributed preservation approach maximized the probability that essential knowledge would survive even severe civilizational disruptions. The mathematical precision underlying many mythological narratives suggests deliberate encoding of technical information within story structures designed for memorization and transmission. The use of specific numbers, time periods, and sequential relationships within myths corresponds to astronomical calculations and suggests that storytellers functioned as knowledge keepers responsible for preserving technical information across generations. The entertainment and religious aspects of mythological narratives provided motivation for accurate transmission while disguising the technical content within culturally meaningful frameworks. The mythological preservation of catastrophic memories points toward external cosmic forces that operate beyond Earth's immediate environment, driving the cyclical patterns of destruction and renewal that ancient cultures encoded within their traditions. Modern astrophysical research has revealed that our solar system moves through the galaxy in complex patterns that expose Earth to varying cosmic conditions across vast time periods, creating cyclical environmental pressures that may trigger the catastrophic events preserved in both geological records and cultural memories. The solar system's movement through the Milky Way galaxy follows multiple overlapping cycles that create periodic variations in Earth's cosmic environment. Our entire solar system orbits the galactic center approximately every 250 million years, but superimposed on this vast orbital motion is a smaller oscillation that carries the solar system above and below the galactic plane in a cycle lasting approximately 64 million years. However, recent astronomical observations have identified an additional oscillation pattern with a period of roughly 26,000 years that corresponds remarkably closely to the precessional cycle recognized by ancient civilizations. This shorter oscillation results from gravitational interactions between the solar system and the spiral density waves that create the galaxy's distinctive arm structure. As our solar system moves through its galactic orbit, it encounters regions of varying stellar density and gravitational influence that cause periodic deflections in its trajectory. These deflections create a complex three-dimensional path through galactic space that brings the solar system into closer contact with different cosmic environments at regular intervals. The galactic plane itself contains elevated concentrations of cosmic dust, gas clouds, and stellar debris that can significantly affect conditions within the solar system when encountered. As the solar system oscillates above and below this plane, it periodically passes through regions of increased particle density that can influence solar activity, planetary magnetic fields, and atmospheric chemistry. The timing of these passages through dense galactic regions appears to correlate with periods of increased geological activity and environmental disruption documented in Earth's stratigraphic record. Astronomical measurements of nearby star positions and galactic structure indicate that the solar system currently occupies a position slightly above the galactic plane and is moving towards maximum displacement in this oscillation cycle. Calculations suggest that the solar system reached its previous maximum displacement approximately 13,000 years ago, placing this event precisely at the end of the Younger Dryas period. This correlation between galactic positioning and terrestrial catastrophic events suggests a causal relationship between cosmic cycles and the environmental disruptions that have shaped human civilization. The density variations encountered during galactic oscillations affect solar activity through mechanisms that remain partially understood, but appear to involve changes in the cosmic ray flux reaching the solar system and alterations in the interstellar medium surrounding the Sun. When the solar system passes through regions of increased particle density, the additional material can compress the heliosphere, the bubble of solar wind that normally shields the inner solar system from galactic cosmic radiation. This compression allows increased cosmic ray penetration to planetary atmospheres and surfaces. Solar minimum and maximum periods demonstrate clear correlations with historical climate changes that extend far beyond the familiar 11-year sunspot cycle. Extended periods of reduced solar activity, such as the Maunder minimum from 1645 to 1715 AD, coincided with the most severe phase of the Little Ice Age in Europe and North America. During this period, average temperatures dropped by 1–2 degrees Celsius across much of the Northern Hemisphere, causing widespread crop failures, social unrest, and demographic disruptions that reshaped European civilization. The Maunder minimum represents just one example of longer solar cycles that operate on timescales of centuries to millennia. Analysis of solar proxy data from ice cores, tree rings, and other paleoclimatic indicators reveals recurring patterns of solar variability that appear to follow regular cycles of approximately 200, 400, 1000, and 2400 years. These longer solar cycles correlate with major climate transitions, including the medieval warm period, the Roman warm period, and earlier climatic episodes that influenced the rise and fall of civilizations across multiple continents. The relationship between solar activity and societal development becomes particularly evident when examining the timing of technological innovations and cultural achievements relative to solar maximum periods. The Renaissance coincided with increased solar activity following the medieval solar minimum, while the classical Greek and Roman civilizations flourished during periods of enhanced solar output. Conversely, major civilizational collapses often correlate with extended solar minimum periods that disrupted agricultural systems and triggered social instability. The Bronze Age collapse around 1200 BC occurred during a period of reduced solar activity that contributed to widespread drought conditions across the eastern Mediterranean and Near East. Archaeological evidence shows simultaneous abandonment of major urban centres from Anatolia to the Levant, with many sites showing evidence of sudden destruction, followed by long periods of reduced occupation. The collapse eliminated several major civilizations, including the Mycenaean Greeks, the Hittite Empire, and numerous Canaanite city-states, creating a dark age that lasted several centuries. The correlation between solar activity and technological development may result from the relationship between cosmic ray exposure and human cognitive function. During solar minimum periods, reduced solar wind strength allows increased cosmic radiation to penetrate Earth's magnetosphere and atmosphere, exposing human populations to elevated levels of high-energy particles. Laboratory studies have demonstrated that cosmic ray exposure can affect neural function, potentially influencing creativity, problem-solving abilities, and technological innovation at the population level. The mechanism linking cosmic ray exposure to cognitive enhancement appears to involve the interaction between high-energy particles and neural tissue, potentially stimulating increased neural connectivity and enhanced pattern recognition abilities. Historical analysis reveals that periods of increased cosmic ray flux corresponding to solar minimum conditions often coincide with bursts of scientific discovery, artistic achievement, and technological innovation. The scientific revolution of the 16th and 17th centuries occurred during the Spora and Maunder solar minima, while the Industrial Revolution began during another period of reduced solar activity. Conversely, periods of very high cosmic ray exposure, such as those that might occur during passage through dense galactic regions, could produce detrimental effects on human physiology and cognitive function. The environmental catastrophes associated with the Younger Dryas and similar events may have resulted from exposure to cosmic ray levels far exceeding normal background radiation, potentially contributing to the social disruptions and technological regressions documented during these periods. The galactic current sheet represents one of the most significant cosmic structures affecting solar system dynamics, though its existence and properties remain subjects of ongoing astronomical research. This theoretical structure consists of a thin layer of electrical current flowing through the galactic plane, created by the rotation of charged particles within the galaxy's magnetic field. The current sheet's magnetic field lines extend perpendicular to the galactic plane, creating a vast magnetic structure that influences the behavior of charged particles throughout the galaxy. As the solar system oscillates above and below the galactic plane during its 25,000-year cycle, it periodically encounters and crosses through this current sheet. The crossing events expose the solar system to intense magnetic fields and electrical currents that can dramatically affect solar activity and planetary magnetic field behavior. The timing of current sheet crossings appears to correlate with major geomagnetic events documented in Earth's paleomagnetic record, including magnetic pole reversals and excursions. The most recent crossing of the galactic current sheet may have occurred approximately 13,000 years ago, coinciding with the Lechamp geomagnetic excursion and the environmental disruptions of the Younger Dryas period. During current sheet encounters, the interaction between galactic and solar magnetic fields can trigger massive solar storms, coronal mass ejections, and other space weather events far exceeding anything observed during recorded history. These extreme solar events could produce the types of environmental catastrophes preserved in geological records and cultural memories worldwide. The electrical properties of the galactic current sheet may also influence planetary atmospheric chemistry through mechanisms involving lightning frequency, atmospheric ionization, and cloud formation processes. Increased electrical activity in Earth's atmosphere during current sheet encounters could trigger more frequent and intense lightning storms, potentially contributing to the massive wildfires documented at catastrophic boundaries in the geological record. The ionization of atmospheric gases could also affect precipitation patterns and storm development, leading to the extreme weather conditions described in flood myths and destruction narratives. Current sheet crossings appear to occur in pairs, with the solar system encountering the sheet structure twice during each complete oscillation cycle as it passes through the galactic plane in both directions. This double-crossing pattern may explain the apparent clustering of catastrophic events in the geological record, with major environmental disruptions occurring at roughly 13,000 year intervals. The asymmetry and crossing effects could result from differences in the solar system's approach angle and velocity during upward versus downward passages through the current sheet. The influence of galactic magnetic fields on solar activity extends beyond current sheet encounters to include the ongoing effects of the local galactic magnetic field environment. The solar system currently moves through a region of space known as the local interstellar cloud, which contains elevated magnetic field strengths that may be affecting solar behavior in subtle but significant ways. Changes in the local galactic magnetic field can alter the structure of the heliosphere and modify the solar wind's interaction with planetary magnetospheres. recent observations have detected changes in the properties of the local interstellar cloud that suggest the solar system is approaching a boundary region where magnetic field strength and particle density may increase significantly. This transition could trigger enhanced solar activity and increased cosmic ray penetration over the coming centuries, potentially affecting Earth's climate and atmospheric chemistry in ways that parallel historical patterns associated with cosmic cycle transitions. The relationship between galactic positioning and solar magnetic field behavior appears particularly important for understanding long-term patterns of geomagnetic instability. Earth's magnetic field strength has declined by approximately 10% over the past 150 years, while the magnetic poles have accelerated their movement patterns in ways that suggest an approaching magnetic excursion or reversal event. These changes may reflect the solar system's current position within galactic magnetic field structures and its approach toward another significant cosmic cycle transition. Paleomagnetic records reveal that geomagnetic excursions and reversals cluster at intervals that correspond to the galactic oscillation cycle, with major magnetic field disruptions occurring approximately every 13,000 years during certain epochs. The Blake event at 120,000 years ago, the Lachamp excursion at 41,000 years ago, and other documented magnetic anomalies appear to follow patterns related to the solar system's galactic positioning and its encounters with cosmic structures like the current sheet. The implications of these cosmic cycles for contemporary civilization become particularly relevant given current astronomical observations indicating that the solar system approaches another significant transition point within its galactic oscillation. If the patterns documented in geological and historical records continue, the coming centuries may witness increased solar activity, geomagnetic instability, and environmental disruptions similar to those that have shaped human civilization throughout its development. The technological vulnerability of modern civilization to space weather events and geomagnetic disturbances creates unprecedented risks during cosmic cycle transitions. The electrical infrastructure, satellite communications, and computer systems that underpin contemporary society could suffer catastrophic damage from the types of solar storms and magnetic field disruptions associated with galactic current sheet encounters. Unlike previous civilizations that preserved knowledge through oral traditions and stone monuments, modern information storage systems remain highly vulnerable to electromagnetic disruption. Understanding the cosmic cycles that drive these recurring catastrophic events provides crucial insights for developing strategies to preserve human knowledge and technological capabilities through future transition periods. The ancient civilizations that successfully transmitted astronomical knowledge across multiple catastrophic cycles employed redundant preservation systems designed to survive environmental disasters and social disruptions. Modern civilization may need to adopt similar approaches, creating knowledge preservation systems that can function independently of vulnerable electronic infrastructure and complex supply chains. The recognition that Earth's history follows cyclical patterns driven by cosmic forces operating on 25,000 year timescales fundamentally challenges linear models of human progress and environmental change. Rather than viewing catastrophic events as random disasters, this perspective suggests that such events represent predictable consequences of the solar system's movement through varying galactic environments. The ancient cultures that developed sophisticated astronomical knowledge and cyclical time concepts may have understood these cosmic relationships far better than conventional historical models suggest. The convergence of astronomical observations, geological evidence, and cultural traditions around 25,000 year cycles indicates that human civilization has developed within a cosmic framework that periodically subjects Earth to environmental pressures capable of disrupting even advanced societies. The survivors of previous catastrophic cycles preserved crucial knowledge about these cosmic relationships through architectural monuments, mathematical systems, and mythological narratives designed to transmit temporal information across multiple generations and cultural transitions. The cosmic cycles that drive Earth's environmental catastrophes operate not only on physical systems, but appear to influence the very fabric of human consciousness itself, creating patterns of psychological and spiritual development that mirror the astronomical rhythms recognized by ancient civilizations. Carl Jung's groundbreaking work on the collective unconscious revealed that human psyche contains inherited patterns of thought and behavior that transcend individual experience, suggesting that species-wide memories might persist across the vast temporal scales associated with precessional cycles. Jung's concept of archetypes describes universal symbols and behavioral patterns that appear consistently across cultures despite geographical isolation and historical separation. These archetypal images, the Great Mother, the Wise Old Man, the hero's journey, the world tree, emerge spontaneously in dreams, myths, and artistic expressions worldwide with remarkable consistency. Jung observed that these patterns seemed to carry information that exceeded what individuals could acquire through personal experience or cultural transmission, leading him to propose that human consciousness contains inherited memory structures passed down through genetic and psychological mechanisms. The archetypal pattern of the Great Flood appears with extraordinary consistency across cultures that had no historical contact, suggesting that this narrative preserves actual species memory of catastrophic events rather than independent mythological invention. Jung noted that flood symbolism in dreams and psychological analysis often represents profound transformation and renewal, with the destructive waters clearing away obsolete psychological structures to enable new growth. The universality of flood imagery in both individual psychology and cultural mythology suggests that catastrophic renewal represents a fundamental pattern embedded within human consciousness. The world tree archetype demonstrates similar universality, appearing in Norse Yggdrasil, Hindu Kalpadruma, Mayan cosmic Cecropia, and countless other cultural traditions as a central axis connecting different levels of reality. Jung interpreted tree symbolism as representing the growth of consciousness itself, with roots extending into unconscious depths and branches reaching toward transcendent awareness. The cyclical death and renewal of the world tree in various mythologies may preserve memories of how consciousness itself undergoes periodic transformation in response to cosmic cycles. The dying and rising god archetype that Jung identified across numerous cultures, Osiris, Tammuz, Dionysus, Quetzalcoatl, follows patterns that correspond to both seasonal cycles and longer temporal rhythms. These figures typically undergo dismemberment or death followed by resurrection, often associated with specific astronomical events and time periods that align with precessional calculations. Jung observed that this archetypal pattern represents the cyclical death and rebirth of consciousness itself, with periodic dissolution of existing mental structures enabling the emergence of renewed awareness. Modern research into genetic memory mechanisms has revealed that traumatic experiences can indeed be transmitted across generations through epigenetic modifications that alter gene expression patterns. Studies of Holocaust survivors and their descendants have documented how severe trauma creates molecular changes that affect stress response systems in subsequent generations. These findings suggest biological mechanisms through which species-wide catastrophic experiences could be preserved within human genetic material and influence the psychological patterns of descendant populations. The phenomenon of cellular memory in organ transplant recipients provides additional evidence for non-neurological information storage within human biology. Recipients of heart, liver, and other organ transplants have reported acquiring memories, preferences, and behavioral patterns that belong to their organ donors. These cases suggest that human tissues contain information storage mechanisms beyond conventional neurological memory, potentially including memories that could persist across much longer time periods than previously recognized. Edgar Cayce's psychic readings, conducted between 1901 and 1944, provided detailed descriptions of Atlantean civilization and its destruction that correlate remarkably with geological evidence for catastrophic events during the Younger Dryas period. Cayce described Atlantis as a technologically advanced civilization that existed for thousands of years before being destroyed by massive geological upheavals around 10,000 BC. His readings included specific details about Atlantean technology, social organization, and spiritual practices that anticipated many later archaeological discoveries. The Cayce readings described Atlantean crystal technology that could harness and direct natural energies for various purposes, including healing, transportation, and communication across vast distances. These descriptions preceded the development of laser technology and fiber optic communications by several decades, suggesting access to information beyond conventional knowledge sources. The readings also described how misuse of these powerful technologies contributed to the geological instabilities that ultimately destroyed Atlantean civilization. Cayce's descriptions of the Atlantean destruction included three major catastrophic periods, occurring approximately 50,000, 28,000, and 10,000 years ago, with the final destruction coinciding with massive flooding and geological upheavals that scattered survivors across the globe. The 10,000 BC date for the final destruction aligns closely with the end of the Younger Dryas period and the massive sea level changes that occurred as Ice Age glaciers melted rapidly. The scattered survivor populations described in the readings correspond to the sudden appearance of advanced agricultural and architectural techniques in various locations worldwide during the early Holocene period. The readings described how Atlantean survivors carried advanced knowledge to Egypt, Peru, the Yucatan, and other locations, establishing mystery schools and sacred sites designed to preserve crucial information through future catastrophic cycles. These descriptions align with archaeological evidence for the sudden appearance of sophisticated astronomical knowledge, architectural techniques, and mathematical systems in these regions during the post-Younger Dryas period. The Cayce material suggested that monuments like the Great Pyramid and Sphinx were built by or under the guidance of Atlantean survivors to preserve knowledge for future civilizations. Cayce's readings also described cyclical patterns of human spiritual development that correspond to astronomical cycles, with periods of enhanced psychic abilities and spiritual awareness alternating with phases of material focus and technological development. According to the readings, humanity undergoes roughly 26,000-year cycles of consciousness evolution that align with precessional periods, with each cycle bringing opportunities for spiritual advancement, followed by periods of testing through material challenges and potential catastrophic events. The phenomenon of spontaneous past life memories in young children, documented extensively by researchers like Ian Stevenson and Jim Tucker, provides additional evidence for consciousness continuity across lifetimes and potentially across much longer time periods. Children who report detailed memories of previous lives often describe experiences from historical periods and geographical locations they could not have learned about through normal means. Some cases involve memories of catastrophic events like floods, earthquakes, and social upheavals that align with documented historical disasters. The accuracy of verifiable details in these past life memory cases suggests that consciousness may indeed preserve experiential information across death and rebirth cycles. If individual consciousness can retain memories across lifetimes, collective human consciousness might preserve species-wide memories of major catastrophic events across the much longer time periods associated with cosmic cycles. The archetypal patterns identified by Jung could represent the psychological residue of these preserved catastrophic memories. Prophetic traditions across cultures have consistently anticipated cyclical changes in human civilization and consciousness, often providing specific timeframes that correspond to astronomical calculations. The Hopi prophecies describe a series of world ages ending in destruction and renewal, with the current fourth world approaching its completion through environmental catastrophes and social upheavals. The prophecies include specific signs and timeframes that align with contemporary global changes and astronomical events. The Hindu tradition of Kalki Avatar describes the appearance of a divine figure who will end the current Kali Yuga and initiate a new golden age, with various texts providing calculations that place this transition in the relatively near future based on precessional cycles. The Puranas describe specific environmental and social conditions that will precede this transition, including widespread natural disasters, social chaos, and the breakdown of traditional knowledge systems. Many of these predicted conditions correspond to contemporary global challenges. Buddhist prophecies describe the coming of Maitreya Buddha, who will appear during a future period of spiritual renewal following a time of great difficulties and social transformation. The timing of Maitreya's appearance is connected to cyclical calculations that relate to both individual karma and cosmic time periods. Tibetan Buddhist traditions preserve detailed chronologies that connect these spiritual cycles to astronomical observations and mathematical calculations extending across thousands of years. The Aztec concept of the fifth sun describes the current world age as approaching its completion through earthquakes and other geological catastrophes, with the timing connected to their sophisticated calendar systems that incorporate precessional cycles. The Maya similarly calculated that major world age transitions would occur at specific dates determined by astronomical observations, with their long count calendar designed to track these vast temporal cycles across multiple millennia. The theory that human consciousness itself evolves in cycles suggests that different historical periods are characterized by distinct modes of awareness and cognitive capability. Ancient civilizations may have possessed forms of consciousness that enabled direct perception of cosmic cycles and their effects on terrestrial systems, while modern consciousness has developed enhanced analytical and technological capabilities at the expense of intuitive cosmic awareness. The shift from right brain dominant consciousness, associated with holistic perception and intuitive knowledge, to left brain dominant awareness, characterized by analytical thinking and technological manipulation, may represent one aspect of these cyclical consciousness changes. Ancient cultures that produced sophisticated astronomical knowledge without apparent technological infrastructure may have operated from consciousness states that enabled direct perception of cosmic relationships and temporal patterns. Julian Jaynes' theory of the bicameral mind proposes that ancient humans operated with a different form of consciousness that included direct communication with what they perceived as divine voices or guidance. According to Jaynes, this bicameral consciousness broke down around 3,000 years ago, forcing humanity to develop self-reflective awareness and analytical thinking as compensation for the loss of direct divine guidance. This transition timing corresponds to various cultural traditions that describe the end of direct divine communication and the beginning of more difficult spiritual conditions. The cyclical nature of consciousness evolution suggests that humanity may be approaching another transition period that could restore enhanced intuitive capabilities while integrating the analytical and technological achievements of the current cycle. The increasing interest in meditation, psychic phenomena, and consciousness research during recent decades may represent early indicators of this approaching transition. The convergence of scientific understanding with ancient wisdom traditions suggests a potential synthesis of technological and spiritual knowledge. Meditation traditions worldwide preserve techniques specifically designed to access information from previous cycles and expanded states of consciousness that transcend normal temporal limitations. Advanced practitioners of various contemplative disciplines report experiences of expanded awareness that include perception of vast time periods, past life memories, and direct knowledge of cosmic cycles and their effects on human development. The Tibetan Buddhist practice of Dzogchen includes techniques for accessing what practitioners describe as the primordial state of consciousness that exists beyond normal temporal limitations. Advanced Dzogchen practitioners report direct perception of the cyclical nature of existence and the recurring patterns that govern both individual karma and collective human development. The tradition preserves detailed instructions for maintaining awareness during death and rebirth processes, potentially enabling continuity of memory across multiple lifetimes. Hindu Raja Yoga traditions include practices specifically designed to access Akashic records, described as a cosmic memory bank that preserves all events and experiences across time. Practitioners who achieve advanced states of samadhi report ability to perceive historical events, future possibilities, and the cyclical patterns that govern human civilization. The Yoga Sutras of Patanjali describe specific techniques for developing these expanded perceptual abilities and accessing information beyond normal sensory limitations. Shamanic traditions across cultures employ altered states of consciousness to access what practitioners describe as non-ordinary reality, including perception of past and future events and communication with spiritual beings who possess knowledge of cosmic cycles. Shamanic journeying techniques enable practitioners to travel through different time periods and access information about cyclical patterns affecting their communities and the broader human species. The use of plant medicines like ayahuasca, psilocybin mushrooms, and other consciousness-altering substances in shamanic traditions often produces experiences that include perception of vast time periods, past life memories, and direct knowledge of cosmic cycles. Research into these substances has revealed their ability to temporarily dissolve normal, ego boundaries and enable access to transpersonal states of consciousness that appear to transcend individual memory limitations. Native American Vision Quest traditions include practices designed to access guidance and knowledge from spiritual sources that transcend normal temporal boundaries. Practitioners often report receiving information about future events, understanding of cyclical patterns affecting their tribes, and direct communication with ancestral spirits who preserve knowledge from previous cycles. These traditions maintain specific protocols for accessing and interpreting this expanded awareness. The phenomenon of mystical experiences across various religious and spiritual traditions consistently includes elements that suggest access to information beyond normal consciousness limitations. Mystics throughout history have reported direct perception of cosmic cycles, past and future events, and understanding of the cyclical patterns governing human spiritual development. These experiences often include specific details about historical events and future possibilities that exceed the mystic's normal knowledge base. Christian mystical traditions include accounts of saints and contemplatives who received visions of past and future events, often including information about cyclical patterns of spiritual renewal and testing. The visions of Hildegard of Bingen included detailed descriptions of cosmic cycles and their effects on human spiritual development, with specific timeframes that correspond to astronomical calculations. Similar prophetic visions appear throughout Christian mystical literature, often providing information about cyclical patterns of spiritual and social transformation. Islamic mystical traditions preserve accounts of advanced practitioners who achieved states of consciousness that enabled perception of cosmic cycles and their effects on human civilization. The works of mystics like Ibn Arabi include detailed descriptions of cyclical time and the recurring patterns that govern both individual spiritual development and collective human evolution. These traditions maintain specific practices for accessing expanded states of consciousness that transcend normal temporal limitations. The consistency of these reports across different cultures and historical periods suggests that human consciousness possesses latent capabilities for accessing information beyond normal memory and sensory limitations. The techniques preserved in various contemplative traditions may represent systematic methods for activating these expanded perceptual abilities and accessing the collective memory banks that preserve species-wide experiences across vast time periods. The integration of ancient wisdom traditions with contemporary consciousness research suggests that human awareness may indeed operate according to cyclical patterns that correspond to astronomical cycles. The approaching transition period, indicated by various prophetic traditions and astronomical calculations, may represent an opportunity for humanity to recover enhanced consciousness capabilities while maintaining the technological and analytical achievements of the current cycle. The preservation of knowledge across catastrophic cycles appears to depend not only on physical monuments and written records, but also on the maintenance of consciousness traditions that enable access to transpersonal memory banks and expanded awareness states. The meditation, shamanic, and mystical traditions that have survived across thousands of years may represent crucial knowledge preservation systems designed to maintain human access to cosmic consciousness and cyclical awareness through periods of material focus and potential catastrophic disruption. The consciousness research and mystical traditions explored in previous chapters find unexpected validation through cutting-edge scientific discoveries that reveal cyclical patterns operating across multiple Earth systems. While ancient cultures preserved knowledge of these cycles through astronomical observations and spiritual practices, contemporary researchers have developed sophisticated analytical tools that confirm the reality of recurring catastrophic events and environmental transitions occurring at intervals that closely match the precessional periods encoded in ancient monuments and mythologies. Douglas Folk's research into solar micronova events represents one of the most significant recent developments in understanding cyclical catastrophes. Working from the De Hold Foundation, Vogt has analysed ice core data, geological records, and astronomical observations to develop a comprehensive theory explaining how our Sun undergoes regular explosive events approximately every 12,000 years. These solar micronovas release enormous amounts of energy and charged particles that can strip away planetary atmospheres, reverse magnetic fields, and trigger massive climate disruptions across the entire solar system. Vogt's analysis of Antarctic ice core data reveals a consistent pattern of cosmic dust and isotopic anomalies appearing at 12,000-year intervals throughout the geological record. The dust layers contain elevated levels of elements typically found in stellar material, suggesting periodic bombardment of Earth by solar ejecta during micronova events. The isotopic signatures include unusual ratios of beryllium-10, carbon-14, and other cosmogenic isotopes that form when cosmic radiation interacts with Earth's atmosphere at levels far exceeding normal background radiation. The mechanism driving these solar micronovas appears related to the accumulation of heavy elements within the Sun's core over thousands of years. As hydrogen fusion proceeds, heavier elements gradually settle toward the solar core, eventually reaching critical concentrations that destabilize the fusion process. When this instability reaches a threshold, the Sun releases a massive burst of energy that expels accumulated heavy elements and resets the core composition for another 12,000-year cycle. Vogt's calculations indicate that the most recent solar micronova occurred approximately 12,000 years ago, coinciding precisely with the Younger Dryas climate catastrophe and the mass extinctions that marked the end of the Pleistocene epoch. The next event, according to his projections, should occur sometime between 2030 and 2050 AD, based on current solar magnetic field behaviour and the accumulation patterns of heavy elements within the solar core. The evidence supporting Vogt's micronova theory extends beyond ice core analysis to include studies of other star systems where similar periodic explosive events have been directly observed. Type Ia supernovae represent extreme examples of stellar instability, while smaller-scale nova events in binary star systems demonstrate how stellar cores can undergo periodic explosive episodes without completely destroying the host star. Our Sun's position as a single star system may produce micronova events that fall between these extremes in terms of energy output and frequency. Randall Carlson's geological research has independently confirmed many aspects of cyclical catastrophism through detailed field studies of landscape features that preserve evidence of massive flood events and cosmic impacts. Working across North America, Carlson has documented extensive geological formations that could only result from catastrophic water releases far exceeding any historical floods. The channeled scablands of eastern Washington state preserve clear evidence of repeated megafloods that carved enormous canyons and transported massive boulders across hundreds of miles during brief periods of catastrophic water flow. Carlson's analysis reveals that these megafloods occurred in cycles corresponding to the termination of Ice Age periods, with the most recent events dating to approximately 12,000, 15,000 years ago. The flood features include giant current ripples, enormous gravel bars, and plunge pools that dwarf any formations created by normal river systems. The scale of these features indicates water flows that exceeded the combined discharge of all current world rivers by factors of hundreds or thousands, suggesting catastrophic ice dam failures or other mechanisms capable of releasing vast quantities of water in short time periods. The Younger Dryas impact hypothesis has gained substantial support through Carlson's field research, which has identified impact markers across multiple continents dating to the onset of the Younger Dryas period. These markers include microscopic diamonds, shocked quartz grains, and elevated concentrations of platinum group elements that typically indicate extraterrestrial material. The distribution of these impact indicators suggests multiple simultaneous impacts or airbursts across North America, Europe, and possibly other continents around 12,900 years ago. Carlson's work has also identified cyclical patterns in impact crater formation that correspond to Earth's encounters with specific meteor streams and comet debris fields. The Taurid meteor complex, which Earth encounters twice annually, contains fragments from Comet Encke and potentially other disrupted comets that pose recurring impact risks. Astronomical calculations indicate that Earth's orbit brings it into denser regions of this debris field at intervals related to precessional cycles, creating periods of elevated impact probability approximately every 12,000, 13,000 years. The relationship between cosmic impacts and climate change appears more complex than simple cause and effect relationships, with impacts potentially triggering cascading environmental changes that persist for centuries or millennia. The Younger Dryas cooling event lasted approximately 1,200 years, far longer than the immediate effects of impact events would suggest. Carlson's research indicates that impacts may destabilize ice sheets, alter ocean circulation patterns, and modify atmospheric chemistry in ways that create long-lasting climate disruptions. Recent paleoclimatological research has revealed additional evidence for cyclical climate patterns through high-resolution analysis of marine sediment cores, lake varves, and other geological archives that preserve detailed records of past environmental conditions. These studies have identified recurring patterns of rapid climate change that occur at intervals closely matching astronomical cycles, including both precessional periods and shorter cycles related to solar activity variations. The North Atlantic Deep Water Formation System, which drives global ocean circulation, appears particularly sensitive to the types of rapid environmental changes associated with cyclical catastrophes. Marine sediment cores from the North Atlantic reveal repeated disruptions of this circulation system at intervals that correlate with other cyclical patterns in the geological record. When North Atlantic deep water formation shuts down or weakens significantly, global climate patterns shift dramatically within decades, triggering widespread environmental changes across multiple continents. Genetic research into human population bottlenecks has provided compelling biological evidence for cyclical catastrophes that severely reduced human numbers at regular intervals throughout our species' history. Analysis of mitochondrial DNA and Y chromosome lineages reveals multiple bottleneck events where human populations drop to extremely low levels before recovering and expanding again. The most recent major bottleneck occurred approximately 15,000 years ago, coinciding with the environmental catastrophes of the Younger Dryas period. The genetic evidence indicates that human populations may have dropped to as few as several thousand individuals during the most severe bottleneck events, with recovery taking centuries or millennia as environmental conditions stabilized and populations gradually expanded. These bottlenecks appear to occur at intervals that match the cyclical patterns identified in geological and astronomical records, suggesting that environmental catastrophes have repeatedly brought human civilization to the brink of extinction throughout our species' development. The distribution of genetic lineages across modern populations reveals patterns consistent with rapid expansion from small founder groups following bottleneck events. The relatively low genetic diversity within human populations compared to other primate species indicates that our species has undergone recent and severe population reductions that eliminated much of our ancestral genetic variation. The timing of these genetic bottlenecks corresponds to the catastrophic events preserved in geological records and cultural memories worldwide. Studies of other mammalian species reveal similar patterns of cyclical population bottlenecks that coincide with the environmental transitions documented in the geological record. Large mammal species appear particularly vulnerable to the types of rapid environmental changes associated with cosmic impacts and solar events, with many species experiencing severe population reductions or complete extinction during catastrophic periods. The Pleistocene megafauna extinctions represent the most recent example of this pattern, but similar extinction events appear throughout the fossil record at intervals that suggest cyclical causation. Plasma cosmology and electric universe theories have emerged as alternative frameworks for understanding solar system dynamics and their relationship to galactic scale phenomena. These theories propose that electromagnetic forces play a much larger role in cosmic evolution than conventional gravitational models suggest, with electrical currents and magnetic fields creating connections between stellar systems and galactic structures that can transmit energy and information across vast distances. The electric universe model suggests that stars, including our Sun, function as electrical phenomena connected to galactic current systems rather than isolated fusion reactors operating independently of their cosmic environment. According to this theory, changes in galactic electrical conditions can directly affect stellar behavior, potentially triggering the types of solar instabilities proposed in micronova theories. The Sun's magnetic field variations and solar cycle behavior may reflect changes in the electrical environment as our solar system moves through different regions of galactic space. Plasma physicist Wallace Thornhill has developed detailed models showing how electrical discharges between celestial bodies could create many of the surface features observed on planets and moons throughout the solar system. According to electric universe theory, the scarred landscapes of Mars, the unusual surface patterns on Jupiter's moons, and even some features of Earth's geography may result from massive electrical discharges that occurred during periods of solar system instability. These discharge events could be triggered by changes in the galactic electrical environment that occur as our solar system moves through its cosmic cycles. The galactic current sheet, proposed as a thin layer of electrical current flowing through the galactic plane, represents a key component of electric universe models that could explain cyclical catastrophes on Earth. As our solar system oscillates above and below the galactic plane during its 25,000-year cycle, it would periodically encounter this current sheet structure, exposing the entire solar system to intense electrical fields and magnetic forces. The interaction between solar and galactic electrical systems during current sheet crossings could trigger the types of solar instabilities and planetary magnetic field disruptions documented in geological records. Modern astronomical observations have provided increasing support for the existence of large-scale electrical phenomena in cosmic space. The detection of magnetic fields throughout the galaxy, the observation of high-energy particle jets from galactic centers, and the discovery of vast filamentary structures connecting different regions of the universe all suggest that electromagnetic forces operate on scales far exceeding conventional theoretical predictions. These observations lend credibility to electric universe theories that propose electrical connections between stellar systems and galactic structures. The Voyager spacecraft missions have revealed unexpected phenomena at the boundaries of our solar system that support electric universe predictions. The heliopause region, where solar wind encounters the interstellar medium, displays electrical and magnetic properties that differ significantly from conventional theoretical expectations. The detection of energetic particle acceleration and magnetic field interactions in this region suggests that our solar system exists within a complex electromagnetic environment that could influence solar behavior in ways not accounted for by traditional models. Recent discoveries of exoplanetary systems have revealed orbital arrangements and planetary characteristics that challenge conventional formation theories while supporting electric universe alternatives. The detection of hot Jupiters orbiting extremely close to their parent stars, the discovery of planets with retrograde orbits, and the observation of stellar systems with unusual magnetic field configurations all suggest that electromagnetic forces may play larger roles in planetary system evolution than previously recognized. The study of comets has provided additional evidence supporting electric universe theories through observations of comet behavior that conventional models cannot adequately explain. Comets display electrical phenomena including plasma tails, X-ray emissions, and surface modifications that suggest interaction with electrical fields throughout the solar system. The Deep Impact mission's collision with Comet Tempel 1 produced results that differed significantly from predictions based on conventional dirty snowball models, instead supporting theories that comets function as electrical phenomena within the solar system's electromagnetic environment. Laboratory plasma experiments have demonstrated that many astronomical phenomena can be reproduced through electrical discharge processes operating under conditions similar to those found in cosmic space. These experiments have created spiral galaxy structures, stellar formation patterns, and planetary surface features through controlled electrical discharges, suggesting that similar processes operating on cosmic scales could explain many observed astronomical phenomena. The scalability of plasma physics allows laboratory results to be extrapolated to cosmic dimensions with greater confidence than many other physical processes. The implications of electric universe theories for understanding cyclical catastrophes extend beyond solar system dynamics to include potential mechanisms for information transfer and consciousness evolution across cosmic scales. If electromagnetic connections exist between stellar systems and galactic structures, these connections could facilitate the types of consciousness evolution and collective memory phenomena discussed in previous chapters. The cyclical nature of galactic electromagnetic conditions could influence biological and psychological processes on Earth in ways that create the recurring patterns of human development preserved in ancient traditions. The convergence of evidence from multiple scientific disciplines, paleoclimatology, genetics, plasma physics, and astronomy, creates a compelling case for cyclical catastrophes operating on timescales that match the astronomical cycles recognized by ancient civilizations. Rather than representing primitive superstitions or mythological inventions, the ancient knowledge of cosmic cycles appears to preserve accurate information about recurring environmental pressures that have shaped human civilization throughout its development. The sophisticated astronomical observations and mathematical calculations preserved in ancient monuments and texts may represent the accumulated wisdom of previous civilizations that survived multiple catastrophic cycles and understood the cosmic forces driving these recurring events. The technological capabilities of modern civilization create both opportunities and vulnerabilities during cosmic cycle transitions. While contemporary scientific instruments can detect and analyze the subtle indicators of approaching catastrophic events, our dependence on electrical infrastructure and electronic systems creates unprecedented risks during periods of solar instability and geomagnetic disruption. The ancient knowledge preservation systems that successfully transmitted crucial information across multiple catastrophic cycles may provide essential guidance for developing modern strategies to maintain human knowledge and capabilities through future transition periods. The convergence of scientific evidence for cyclical catastrophes reveals a disturbing pattern when examined alongside the history of human technological development. Many of our most significant innovations appear to represent rediscoveries rather than original inventions, suggesting that previous civilizations achieved similar or superior technological capabilities before being destroyed by the cosmic cycles that modern research has begun to understand. This pattern of technological regression and recovery extends across multiple disciplines, from metallurgy and engineering to astronomy and mathematics, creating a compelling case that human civilization has repeatedly risen to advanced levels only to lose accumulated knowledge during catastrophic transitions. The metallurgical sophistication evident in ancient artifacts challenges conventional timelines of technological development in ways that suggest previous advanced civilizations possessed techniques that modern science has only recently rediscovered, or in some cases still cannot replicate. The Iron Pillar of Delhi, erected sometime between 375 and 415 AD, demonstrates corrosion resistance properties that exceed modern steel alloys through the use of phosphorus concentrations and forging techniques that contemporary metallurgists struggle to explain. The pillar has withstood over 1,600 years of monsoon exposure without significant rust formation, indicating mastery of metallurgical principles that were supposedly unknown during the classical period. Analysis of the pillar's composition reveals a unique microstructure created through forge welding techniques that produce a protective phosphoric compound coating. This coating forms through specific heating and hammering processes that require precise temperature control and timing sequences that modern foundries have difficulty replicating consistently. The pillar's creators understood complex relationships between phosphorus content, carbon distribution, and grain structure that were not formally recognized by Western metallurgy until the 20th century, yet they applied this knowledge to create a monument that surpasses modern corrosion resistance standards. The Antikythera mechanism, discovered in a Roman-era shipwreck off the Greek coast, represents perhaps the most striking example of technological sophistication that disappeared from the historical record for over a millennium. This bronze device, dating to approximately 100 BC, functions as an analog computer capable of predicting the positions of the sun, moon, and planets across multiple years with remarkable accuracy. The mechanism incorporates differential gears, epicyclic gear trains, and complex mechanical calculations that were not seen again in European technology until astronomical clocks appeared in the 14th century. The device's gear ratios encode sophisticated astronomical knowledge, including the 19-year Metonic cycle, the 76-year Callipic cycle, and the 223-month Saros cycle used for eclipse prediction. The mechanism tracks the elliptical orbit of the Moon through a pin and slot device that varies the lunar calendar's speed relative to the solar calendar, demonstrating understanding of Hipparchus's lunar theory that was supposedly lost until Kepler's work in the 17th century. The bronze gears were cut with precision that requires advanced machining techniques, suggesting manufacturing capabilities that conventional archaeology does not associate with ancient Greek civilization. Recent CT scanning and 3D modelling of the Antikythera mechanism fragments have revealed additional complexity, including subsidiary dials that track planetary cycles and possibly stellar positions related to precessional calculations. The device appears to have incorporated knowledge of planetary periods that were not rediscovered until Copernican astronomy, while its mechanical implementation of complex astronomical calculations parallels the analog computers developed during World War II. The sophistication of this single artifact suggests that ancient Greek civilization possessed technological capabilities that disappeared almost entirely from the historical record. The precision stone cutting evident at megalithic sites worldwide demonstrates masonry techniques that modern construction struggles to replicate, despite access to advanced power tools and engineering equipment. The blocks at Sacsayhuaman in Peru fit together with tolerances measured in fractions of millimeters, creating joints so precise that knife blades cannot be inserted between adjacent stones. These massive blocks, some weighing over 100 tons, were shaped into complex polygonal forms that interlock in 3 dimensions, requiring understanding of structural engineering principles and manufacturing capabilities that exceed most contemporary construction projects. The surfaces of these precisely fitted blocks show evidence of machining marks that suggest the use of advanced cutting tools, rather than the bronze implements that conventional archaeology associates with pre-Columbian civilizations. Microscopic analysis reveals parallel striations and uniform surface textures that typically result from powered cutting equipment operating at consistent speeds and feed rates. The geometric precision of the cuts, particularly the complex angles required for polygonal fitting, indicates the use of sophisticated measuring instruments and possibly computer-controlled machining processes. Similar precision stonework appears at sites across multiple continents, including the Temple of Jupiter at Baalbek in Lebanon, where foundation blocks weighing over 800 tons were cut, transported, and positioned with tolerances that challenge modern, heavy construction capabilities. The trilithon stones at Baalbek display evidence of advanced quarrying techniques, including perfectly straight cuts through limestone that would require diamond-tipped saws or laser cutting equipment to achieve with comparable precision. The logistics of moving and positioning these massive blocks would challenge contemporary construction projects, even with modern cranes and transportation equipment. Ancient texts from multiple civilizations contain descriptions of advanced technologies that closely parallel modern scientific achievements, suggesting that previous cultures possessed sophisticated understanding of physics, chemistry, and engineering principles that were subsequently lost and only recently rediscovered. The Sanskrit epic Mahabharata describes Vimanas, flying vehicles capable of travelling vast distances and engaging in aerial combat, using weapons that produce effects resembling nuclear explosions. These descriptions include technical details about propulsion systems, navigation equipment, and defensive capabilities that anticipate many aspects of modern aerospace technology. The Vimana descriptions in texts like the Vaimanika Shastra provide specific technical information, including materials specifications, engine designs, and operational procedures that demonstrate sophisticated understanding of aerodynamics and propulsion physics. The texts describe mercury-based propulsion systems that generate lift through electromagnetic effects, anticipating principles that modern physics has only recently begun to explore through experimental anti-gravity research. The navigation systems described in these texts include devices for detecting enemy aircraft, weather monitoring equipment, and communication systems that parallel modern avionics technology. The Ramayana contains additional descriptions of advanced weapons, including the Brahmastra, described as a projectile that could destroy entire armies and leave the battlefield radioactive for years afterward. The text provides specific details about the weapon's effects, including descriptions of intense light, heat that could melt metal, and lingering contamination that prevented vegetation growth and caused hair and nails to fall out among survivors. These descriptions closely match the documented effects of nuclear weapons, including radiation sickness symptoms that were unknown to ancient writers unless they had direct knowledge of such phenomena. Egyptian hieroglyphic texts contain references to advanced technologies including devices for generating artificial light, methods for preserving organic materials indefinitely, and techniques for cutting and shaping stone using focused energy beams. The Dendra Temple complex contains reliefs that appear to depict electrical devices including what researchers have interpreted as incandescent bulbs, electrical cables, and power generation equipment. While conventional Egyptology interprets these images symbolically, electrical engineers who have analysed the reliefs note striking similarities to functional electrical circuit diagrams. The Baghdad Battery, a clay jar containing copper and iron electrodes dating to approximately 250 BC, demonstrates that ancient Mesopotamian civilizations possessed practical knowledge of electrochemistry centuries before Luigi Galvani's formal discovery of bioelectricity. When filled with acidic solution, the device generates approximately 1.1 volts of electrical current, sufficient for electroplating applications or powering small electronic devices. Archaeological evidence suggests that similar batteries were used throughout the ancient Middle East for purposes that remain unclear, but may have included metal plating, medical treatments, or religious ceremonies involving electrical effects. The precision of ancient astronomical calculations reveals mathematical and observational capabilities that rival modern scientific achievements, despite the apparent absence of advanced instruments and computational equipment. The Maya long count calendar incorporates calculations extending over 63 million years with mathematical precision that accounts for leap years, orbital variations, and precessional changes across vast time periods. These calculations require understanding of advanced mathematical concepts, including positional notation, zero as a placeholder, and complex algebraic relationships that were supposedly unknown in pre-Columbian America. Mayan astronomical texts contain accurate predictions of planetary positions, eclipse cycles, and stellar movements that extend thousands of years into both past and future timeframes. The Dresden Codex includes Venus tables that remain accurate across multiple centuries, while also providing calculations for Mars, Jupiter, and other planetary bodies that require sophisticated observational techniques and mathematical analysis. The precision of these astronomical calculations exceeds the accuracy achieved by European astronomy until the development of telescopic observation and Newtonian mechanics. Hindu astronomical texts demonstrate similar mathematical sophistication through calculations of planetary periods, eclipse cycles, and precessional changes that anticipate modern astronomical values by centuries or millennia. The Surya Siddhanta provides mathematical formulas for calculating planetary positions that incorporate elliptical orbits, gravitational perturbations, and relativistic effects that were not formally recognized by Western astronomy until the 20th century. The text's calculations of the length of the solar year differ from modern measurements by less than 2 minutes, demonstrating observational precision that challenges conventional assumptions about ancient scientific capabilities. The acceleration of technological development during recent centuries follows patterns that suggest systematic rediscovery of previously known principles rather than entirely original innovation. The Renaissance period witnessed simultaneous breakthroughs in multiple fields, including astronomy, mathematics, engineering, and physics, that occurred too rapidly to represent independent discoveries by isolated individuals. The clustering of major innovations during specific time periods suggests access to preserved knowledge sources that became available through archaeological discoveries, manuscript translations, or other mechanisms that transmitted ancient wisdom to contemporary researchers. Leonardo da Vinci's notebooks contain designs for helicopters, submarines, tanks, and parachutes that anticipate modern technology by centuries, yet these innovations appeared to emerge fully formed without clear developmental sequences leading to their conception. Da Vinci's technical drawings demonstrate understanding of aerodynamics, hydraulics, and mechanical engineering principles that were supposedly unknown during the Renaissance period. The sophistication of his design suggests access to technical knowledge that exceeded what individual observation and experimentation could reasonably produce within a single lifetime. The rapid development of electromagnetic theory during the 18th and 19th centuries followed patterns suggesting rediscovery of previously understood principles rather than original scientific breakthrough. Researchers like Benjamin Franklin, Luigi Galvani, Alessandro Volta, and Michael Faraday made fundamental discoveries about electrical phenomena within decades of each other, despite working with primitive equipment and limited theoretical frameworks. The speed with which electromagnetic principles were understood and applied suggests that these researchers may have been rediscovering natural laws that previous civilizations had already mastered. The development of atomic theory and nuclear physics during the 20th century occurred with remarkable rapidity once initial theoretical breakthroughs were achieved. Within decades, scientists progressed from discovering radioactivity to building nuclear reactors and weapons, suggesting that the underlying principles were more accessible than entirely original research would indicate. The ancient descriptions of nuclear-like weapons in Sanskrit texts, combined with evidence of possible nuclear events in the archaeological record, raises questions about whether modern nuclear physics represents rediscovery rather than original innovation. Knowledge preservation systems throughout history reveal sophisticated strategies for transmitting technical information across catastrophic periods through multiple redundant storage methods designed to survive environmental disasters and social disruptions. The Library of Alexandria represented one approach to knowledge preservation through centralized collection and copying of texts from across the ancient world, but this strategy proved vulnerable to political upheaval and natural disasters that ultimately destroyed much of the accumulated information. The mystery schools of ancient Egypt, Greece, and other civilizations employed different preservation strategies that distributed crucial knowledge among initiated individuals who memorized complex technical information and transmitted it through oral traditions and symbolic systems. These schools developed elaborate encoding methods that disguised technical knowledge within religious narratives, mythological stories, and architectural symbolism that could survive cultural transitions while preserving essential information for future rediscovery. The medieval monastery system inadvertently preserved many ancient texts through copying and translation activities that maintained knowledge continuity during periods of social upheaval and technological regression. Monastic libraries contained works on mathematics, astronomy, engineering, and natural philosophy that would otherwise have been lost during the collapse of classical civilization. The scholarly activities of medieval monks created redundant copies of crucial texts that enabled the Renaissance recovery of ancient knowledge. Islamic scholars during the medieval period served as crucial intermediaries in preserving and transmitting ancient knowledge from Greek, Persian, and Indian sources to later European civilization. The House of Wisdom in Baghdad and similar institutions collected, translated, and expanded upon ancient texts dealing with mathematics, astronomy, medicine, and engineering. Islamic preservation of ancient knowledge enabled later European rediscovery of classical learning that had been lost in Western Europe during the Dark Ages. The printing press revolutionized knowledge preservation by enabling mass production of identical copies that could be distributed widely enough to survive localized disasters. However, the transition from oral and manuscript traditions to printed materials also created vulnerabilities, as printed books required specific materials, manufacturing processes, and storage conditions that could be disrupted during catastrophic events. The durability of ancient stone monuments and their encoded astronomical information demonstrates advantages of non-textual preservation systems that remain functional even after complete social collapse. Modern digital storage systems represent both the most powerful and most vulnerable knowledge preservation technology ever developed. Digital databases can store vast quantities of information in compact formats and enable rapid searching and cross-referencing capabilities that far exceed traditional library systems. However, digital storage requires complex technological infrastructure, including electricity, computer hardware, software systems, and technical expertise that could be completely disrupted during the types of catastrophic events documented in geological and historical records. The rapid obsolescence of digital storage formats creates additional vulnerabilities that threaten long-term knowledge preservation. Information stored on magnetic tapes, floppy disks, CD-ROMs and other media from recent decades has already become inaccessible due to hardware and software changes, demonstrating how quickly digital information can be lost even without catastrophic events. The complexity of modern digital systems means that future civilizations recovering from catastrophic disruption might lack the technical knowledge necessary to access preserved digital information. The redundancy strategies employed by modern knowledge preservation systems attempt to address these vulnerabilities through multiple backup systems, distributed storage networks, and format migration programs designed to maintain information accessibility across technological transitions. However, these systems remain dependent on the complex industrial civilization that created them and would likely fail completely during the types of environmental catastrophes and social disruptions that have repeatedly affected human civilization throughout its development. The comparison between ancient and modern knowledge preservation strategies reveals that stone monuments, mathematical relationships, and symbolic encoding systems may provide more durable information storage than electronic databases and printed materials. The astronomical knowledge preserved in megalithic structures has remained accessible for thousands of years without requiring maintenance, technical expertise, or industrial support systems. The mathematical constants encoded in pyramid dimensions and other ancient monuments create universal languages that could be interpreted by any technically advanced civilization, regardless of cultural or linguistic barriers. The patterns of technological rediscovery documented throughout human history suggest that our current scientific and technological achievements may represent recovery of capabilities that previous civilizations possessed before being destroyed by the cosmic cycles that modern research has begun to understand. Rather than representing linear progress from a primitive to advanced states, human technological development appears to follow cyclical patterns of achievement, catastrophic loss, and gradual rediscovery that align with the astronomical cycles preserved in ancient knowledge systems. The ancient texts, monuments, and traditions that describe advanced technologies may preserve accurate information about human capabilities during previous cycles, rather than mythological fantasies or primitive misunderstandings of natural phenomena. The technological rediscovery patterns documented throughout human history take on urgent significance when examined alongside current astronomical observations and environmental indicators that suggest we may be approaching another major transition within the 920-year precessional cycle. Multiple lines of evidence point toward our current position as potentially critical within this vast temporal framework, with several key astronomical markers indicating that the next catastrophic phase could commence within the coming decades, rather than centuries. Our solar system's current position relative to the galactic plane places us approximately 27 parsecs above the galactic equator, moving toward the maximum displacement point in our oscillatory path through galactic space. Calculations based on stellar motion data and galactic structure models suggest we reached the previous maximum displacement approximately 13,000 years ago, coinciding precisely with the Younger Dryas catastrophe that marked the end of the last ice age. The symmetrical nature of this oscillation pattern indicates that we should approach another significant transition point as we begin our return journey toward the galactic plane, potentially triggering similar environmental disruptions within the next several decades. The weakening of Earth's magnetic field provides one of the most concerning indicators of approaching instability. Satellite measurements show that magnetic field strength has declined by approximately 10% since direct recordings began in the 1840s, with the rate of decline accelerating significantly during recent decades. The magnetic North Pole has abandoned its relatively stable position in northern Canada and now races towards Siberia at speeds exceeding 50 kilometers per year, compared to the gradual drift of 15 kilometers per year observed throughout most of the 20th century. These magnetic field changes mirror the patterns documented before previous geomagnetic excursions and reversals throughout Earth's history. The Lachamp event at 41,000 years ago and similar magnetic instabilities appear to cluster at intervals that correspond to our solar system's galactic positioning, suggesting that cosmic influences trigger these terrestrial magnetic disruptions. The current magnetic field behavior indicates that Earth may be entering another period of geomagnetic instability that could culminate in a complete pole reversal or excursion within the next few decades. Solar activity patterns provide additional evidence for approaching cyclical transitions through observations of magnetic field behavior and sunspot cycle variations that deviate significantly from normal patterns. The recent solar minimum between cycles 24 and 25 lasted longer and reached deeper levels of inactivity than any comparable period since the Dalton minimum of the early 1800s. Solar magnetic field measurements show unusual configurations and weakening polar fields that some researchers interpret as precursors to more dramatic solar changes. Douglas Vogel's analysis of solar core composition suggests that heavy element accumulation has reached levels comparable to those calculated for previous micronova events. The Sun's magnetic field reversals during each 11-year cycle have become increasingly irregular, with some cycles showing incomplete reversals or unusual magnetic configurations that may indicate approaching instability. Helios's homology data reveals changes in solar interior structure that could reflect the core composition changes predicted by micronova theory. The increasing frequency of large solar flares and coronal mass ejections during recent solar cycles demonstrates elevated solar activity levels that may represent early indicators of approaching major solar events. The Carrington event of 1859 remains the most powerful geomagnetic storm in recorded history, causing telegraph systems to fail across North America and Europe, while producing aurora displays visible as far south as the Caribbean. Contemporary solar observations suggest that similar or more powerful events could occur with increasing probability as solar instability continues to develop. Environmental indicators across multiple Earth systems show patterns of accelerating change that parallel the conditions documented before previous catastrophic transitions. Arctic ice loss has accelerated dramatically during recent decades, with summer sea ice extent declining at rates that exceed most climate model predictions. The Greenland and Antarctic ice sheets show increasing instability through mechanisms including accelerated glacier flow, ice shelf collapse, and increased surface melting that could contribute to rapid sea level changes. Ocean circulation patterns display increasing instability that mirrors the disruptions documented during previous climate transitions. The Atlantic meridional overturning circulation, which drives global ocean heat transport, has weakened significantly during recent decades, and shows signs of approaching a critical threshold that could trigger rapid reorganization. Similar circulation disruptions occurred during the Younger Dryas and other abrupt climate change events, suggesting that current ocean changes may represent early indicators of approaching catastrophic transitions. Atmospheric chemistry measurements reveal increasing concentrations of greenhouse gases and other trace compounds that could amplify the effects of external forcing mechanisms during cosmic cycle transitions. While human activities contribute significantly to these atmospheric changes, the timing of industrial development coincides with our approach toward a major astronomical transition point, potentially creating compound environmental pressures that exceed those experienced during previous cycles. Biological systems worldwide show increasing stress indicators that may reflect subtle environmental changes preceding more dramatic catastrophic events. Species extinction rates have accelerated dramatically during recent centuries, with current extinction rates estimated at 100 to 1,000 times natural background levels. Coral reef bleaching events, forest die-offs, and population crashes among various animal species suggest ecosystem instability that could indicate approaching environmental transitions. The frequency of extreme weather events has increased significantly during recent decades, with record-breaking temperatures, precipitation patterns, and storm intensities occurring with greater regularity. While climate change contributes to these trends, the clustering of extreme events may also reflect the types of environmental instability that precede major catastrophic transitions documented in the geological record. Seismic and volcanic activity patterns show potential correlations with cosmic cycle timing through mechanisms that remain poorly understood but may involve gravitational or electromagnetic influences on crustal stability. The number of large earthquakes and volcanic eruptions has fluctuated throughout recorded history, with some periods showing elevated activity levels that could relate to external forcing mechanisms operating on astronomical timescales. Understanding these cyclical patterns provides crucial insights for addressing contemporary environmental and social challenges through strategies that account for the possibility of approaching catastrophic transitions. Rather than assuming linear progression of current trends, cyclical thinking suggests that human civilization may need to prepare for potential discontinuous changes that could disrupt existing systems and require fundamental adaptations in how we organize society and preserve knowledge. Climate change mitigation efforts take on different significance when viewed within the context of potential cosmic cycle transitions. While reducing greenhouse gas emissions remains important for limiting human contributions to environmental change, the possibility of externally forced catastrophic events suggests that adaptation strategies may prove more crucial than prevention efforts. Preparing for rapid climate transitions, regardless of their ultimate causes, requires developing resilient systems capable of functioning during periods of environmental instability. Energy infrastructure vulnerability represents one of the most critical challenges for maintaining civilization during cosmic cycle transitions. The electrical grids, communication networks, and transportation systems that support modern society remain highly susceptible to disruption from solar storms, geomagnetic events, and other space weather phenomena that could intensify during periods of solar instability. The 1989 Quebec blackout, caused by a relatively minor geomagnetic storm, demonstrates how vulnerable contemporary infrastructure remains to space weather events far less severe than those predicted by micronova theories. Hardening critical infrastructure against electromagnetic disruption requires significant investment in shielding technology, backup systems, and decentralized energy generation that could maintain functionality during severe space weather events. Countries like the United States have begun developing space weather preparedness programs, but current efforts remain inadequate for the types of extreme events that could accompany cosmic cycle transitions. Preparing for potential micronova events would require infrastructure protection measures far exceeding current space weather mitigation efforts. Food security strategies must account for the possibility of rapid climate changes and agricultural disruptions that could result from cosmic cycle transitions. The global food system's dependence on stable climate patterns, predictable seasonal cycles, and complex supply chains creates vulnerabilities that could prove catastrophic during periods of environmental instability. Developing resilient food production systems requires investing in crop varieties adapted to variable climate conditions, distributed food storage networks, and local production capabilities that could function independently of global supply chains. The Svalbard Global Seed Vault and similar genetic preservation projects represent important steps toward maintaining agricultural diversity through potential catastrophic periods, but current efforts remain limited in scope and geographic distribution. Comprehensive food security preparation would require multiple seed preservation facilities, expanded crop genetic diversity, and agricultural techniques adapted to rapidly changing environmental conditions. Water resource management becomes critically important during cosmic cycle transitions that could disrupt normal precipitation patterns and hydrological cycles. The types of rapid climate changes documented during previous catastrophic transitions often involve dramatic alterations in regional water availability, with some areas experiencing severe drought while others faced flooding and excessive precipitation. Developing resilient water systems requires diverse supply sources, extensive storage capacity, and treatment technologies that could function during periods of infrastructure disruption. Knowledge preservation strategies require fundamental reconsideration in light of cyclical catastrophe theories and the vulnerabilities of contemporary information storage systems. Digital databases and electronic archives that contain most of humanity's accumulated knowledge remain highly vulnerable to electromagnetic disruption, infrastructure failure, and the complex technical requirements necessary for accessing stored information. The rapid obsolescence of digital storage formats creates additional risks that could result in information loss even without catastrophic events. Learning from ancient knowledge preservation systems suggests developing multiple redundant storage approaches that combine the advantages of modern technology with the durability of traditional methods. Stone monuments encoded with mathematical and astronomical information have preserved crucial knowledge for thousands of years without requiring maintenance or technical infrastructure. Creating modern equivalents that encode essential scientific and technical information in durable physical formats could ensure knowledge survival through potential catastrophic transitions. The Georgia Guidestones, erected in 1980, represented one attempt to create a modern stone monument encoded with information for future civilizations. Though the monument's focus on population control and social organization provided limited technical knowledge. More comprehensive modern stone archives could encode essential scientific constants, mathematical relationships, technological principles, and historical information in formats designed to remain accessible across potential civilizational disruptions. Distributed knowledge preservation networks that combine multiple storage approaches could maximize the probability of information survival through catastrophic events. These networks might include underground archives, satellite-based storage systems, distributed digital networks, encoded stone monuments, and human memory preservation traditions that collectively ensure crucial knowledge remains accessible regardless of which specific storage system survive potential disasters. Educational systems require restructuring to incorporate cyclical thinking and prepare future generations for the possibility of major civilizational transitions. Traditional educational approaches that assume linear progress and stable environmental conditions may prove inadequate for preparing students to navigate potential catastrophic changes. Curricula that include cyclical history, cosmic influences on terrestrial systems, and resilience strategies could better prepare future leaders to manage civilization through potential transition periods. Practical skills education becomes particularly important when considering the possibility of technological regression during catastrophic transitions. Students who understand fundamental principles of agriculture, engineering, medicine, and other essential technologies could help maintain crucial capabilities even if complex industrial systems become disrupted. Balancing advanced technical education with practical skills training could create more resilient human capital capable of adapting to various future scenarios. International cooperation frameworks need development to address the global nature of cosmic cycle transitions and their potential effects on human civilization. Unlike localized disasters that affect specific regions, cosmic cycle events could simultaneously impact multiple continents and require coordinated responses that transcend national boundaries. Developing international protocols for managing global catastrophic events could improve humanity's collective response capabilities during future transition periods. Space-based observation and early warning systems represent crucial investments for monitoring cosmic cycle indicators and providing advance notice of approaching catastrophic events. Satellite networks dedicated to monitoring solar activity, cosmic ray flux, geomagnetic field behavior, and other relevant parameters could provide the observational data necessary for confirming cyclical theories and predicting the timing of future events. Enhanced space weather monitoring could provide weeks or months of advance warning for some types of cosmic events, enabling protective measures and emergency preparations. The development of space-based civilization infrastructure could provide backup systems that remain functional during terrestrial catastrophic events. Space habitats, lunar bases, and Mars colonies could preserve human knowledge and capabilities through periods when Earth-based civilization faces severe disruption. While current space technology remains limited, continued development of space-based infrastructure could eventually provide insurance against civilizational collapse during cosmic cycle transitions. Scientific research priorities require reorientation toward understanding cosmic cycle mechanisms and developing technologies for managing their effects. Current research funding tends to focus on incremental advances within established paradigms, rather than investigating the types of cyclical phenomena that could fundamentally alter human civilization. Increased investment in solar physics, galactic astronomy, paleoclimatology, and catastrophic event research could provide the scientific foundation necessary for developing effective preparation strategies. Interdisciplinary research approaches become essential for understanding the complex interactions between cosmic, terrestrial, and biological systems during cyclical transitions. The mechanisms linking galactic positioning to solar activity, solar events to terrestrial climate changes, and environmental disruptions to biological and social systems require expertise from multiple scientific disciplines working in coordination. Establishing research programs that integrate astronomy, geology, climatology, biology, and social sciences could accelerate understanding of cyclical phenomena and their implications. The philosophical implications of cyclical history challenge fundamental assumptions about human progress and the nature of civilization itself. Linear progress models that assume continuous advancement from primitive to sophisticated states may need replacement with cyclical frameworks that recognize recurring patterns of rise, decline, and renewal. This shift in perspective could influence how societies plan for the future and allocate resources between short-term optimization and long-term resilience. Religious and spiritual traditions that emphasize cyclical time and cosmic consciousness may provide valuable perspectives for understanding humanity's place within vast temporal cycles. The ancient wisdom traditions that preserved knowledge of cosmic cycles through previous catastrophic periods could offer guidance for maintaining spiritual and psychological resilience during future transitions. Integrating traditional cyclical worldviews with contemporary scientific understanding could create more comprehensive frameworks for navigating potential civilizational challenges. The evidence presented throughout this investigation reveals that Earth's history does indeed appear to follow cyclical patterns operating on approximately 25,000 year timescales, driven by our solar system's movement through varying galactic environments. The astronomical knowledge preserved by ancient civilizations, the geological record of recurring catastrophes, the archaeological evidence for advanced prehistoric cultures, and contemporary scientific discoveries all converge on the reality of cosmic cycles that periodically subject Earth to environmental pressures, capable of disrupting even advanced civilizations. The implications of this cyclical framework extend far beyond academic interest to encompass practical concerns about humanity's immediate future. Multiple indicators suggest that we may be approaching another major transition within the cosmic cycle, with potential catastrophic events possible within the coming decades. Rather than representing inevitable doom, this recognition provides opportunities for preparation and adaptation that could enable human civilization to navigate the approaching transition more successfully than previous cultures. The ancient civilizations that successfully preserved crucial knowledge through previous catastrophic cycles demonstrated that human ingenuity and foresight could overcome even the most severe environmental challenges. The astronomical monuments, mathematical systems, and mythological traditions they created continue to provide guidance for understanding cosmic cycles and preparing for their effects. By combining ancient wisdom with contemporary scientific capabilities, modern civilization possesses unprecedented opportunities to not merely survive the next cosmic cycle transition, but to emerge from it with enhanced knowledge and capabilities. The choice facing contemporary humanity involves whether to continue assuming linear progress and stable environmental conditions, or to acknowledge the cyclical nature of cosmic influences and begin preparing for potential catastrophic transitions. The evidence strongly supports the cyclical interpretation, suggesting that preparation efforts begun now could prove crucial for maintaining human civilization through the challenges that may lie ahead. The ancient legacy of cyclical knowledge, preserved across thousands of years and multiple catastrophic events, offers both warning and hope. Warning of approaching challenges, but also hope that human wisdom and adaptability can successfully navigate even the most dramatic cosmic transitions.